welcome to our data analytics workshop. I know some of you came from very far from PNB. We really appreciate it. So just to give you some background, you know, so I'm the head of the teaching and learning unit in the College of Learning Management Studies, and this is Mr. Rishanta, who is our research assistant in the teaching and learning unit. One of the reasons why we came up with this idea of
Head of polycorrelation. Most of the methods we use, they assume that the data follows a normal distribution. And in most cases, without the normal transformation of the data, we can calculate maybe, say, measures of central tendency, like your mean or a median, and you find that the statistic is not actually capturing the underlying distribution in the data because the distribution does not follow the assumptions that underlie that particular statistic. So there is the issue of data transformation. Then the next thing we look at is data analysis. When we are applying techniques of statistical analysis, machine learning, algorithms, and data mining to extract insights, every statistical method that we use particularly, or statistical model, it has its own assumptions. And in most cases, after running the model, we want to do post-estimation to test the model and to see whether the model actually fits the data that we're using fits the assumptions of the particular model. So we need to also think about that when we preparing the data to bring it to that for data analysis. We want to think about the model we want to use, and we want to make sure that the data is in the structure that meets the assumptions of the model. Then the final is interpretation, where we're trying to make sense of the results, but mostly we also think about our domain of study to say, okay, what do these results mean to the phenomena we are trying to investigate? And we also want to be able to communicate the results to an audience. It can be you are submitting your thesis, your dissertation for marking or for review. It needs to be something that is communicable to the next person, that they are able to understand, and that is also something that they can relate when they compare what you have presented to the principles of the methods and the models that you have used. Also, the issues of reliability and validity. So these are the aspects of data analytics in particular order, from data collection, cleaning, transformation, analysis, and interpretation. So there are broadly two types of data analytics. The first one we talk about is descriptive analytics, and the second one is inferential analytics. So descriptive analytics, we're looking at data in its raw form, and we want to investigate what kind of patterns exist in the data. So sometimes we run summaries to describe the main features, where we calculate the average values, like your mean. We want to see maybe if the data is categorical variables, we want to see the frequencies. We also engage in some other methods in descriptive analysis, like dimension reduction. Let's say we have a very large data set with a lot of variables, but you want to quickly have a view of what are the various dimensions in which these variables can be grouped. And then you transform your data to a homogeneous scale, and you implement dimensional reduction procedures, like your factor analysis, if you're concerned about whether there's a latent structure in the data, or you implement maybe principal components analysis if you are concerned that you want to understand how much of variation is being explained by a correlated set of features. Or maybe you want to do multiple correspondence analysis, where you want to actually group the features of data in a particular way. I think we'll cover most of this when we do hands-on exploratory data analysis to investigate how we think about the structure of data using descriptive analytics. So it gives you a quick overview of the structure and patterns in the data. We think also of univariate analysis of data, where we run maybe graphical visualizations like your histograms, and you want to see the pattern of data values. Is the data a normal distribution? Is it skewed? And if it's skewed, what kind of skewness exists in the data? Can it be transformed to a normal distribution by rescaling or normalization? Or you can see whether is the mode the right metric for this data, or should I use maybe a median or a mean? So tools such as your histograms, bar charts, scatter plots, and box plots are effective, or maybe tools that you use in descriptive analytics. Then in inferential analytics, we are trying to generalize aspects that we find or conclusions we reach from a sample to a larger population. So we want to make inferences. It also boils down to issues of sampling. I think the professor is going to cover that, issues of sampling and why it's important to think about how we collect the data and how we make conclusions and how we also make generalizations from our sample to the larger population. So we use sample statistics to estimate population parameters, issues of random sampling and representative samples that will be covered, as well as hypothesis testing. So what are the questions we are asking when we are looking at inferential statistics? We are saying, what is the chance or the probability of finding the conclusions we are finding in our sample in a larger data set? So we run hypothesis testing, and we look at your metrics such as your p-values, confidence intervals, in order to take our findings from a sample to the larger population from which we extracted the particular sample. Then these are the various applications of data analytics. So you have descriptive analytics, where obviously we want to understand the structure and patterns of data. Mostly when you look at how we do maybe descriptive analytics in our research studies, sometimes you submit, when I was doing my master's, I would submit my thesis, and then the professor says, you need to add your descriptive analysis. And you kind of go there and you want to count how many, how many individuals are males, how many individuals are females. But actually, when you consider the holistic view of your research, you want to be able to give a descriptive assessment of your data that informs the particular methodology you are using in running a predictive model or whatever model you are going to use in reporting the findings of your data. So if I am doing descriptive analysis or analytics on a data, on a variable like gender, I want to be able to inform my audience how the distribution of gender is likely going to influence my conclusions. Like, for example, if females are not as represented as males, maybe there's a larger proportion of males than females in the data, I need to give to give a caution in my research to say that there can be a bias in the fact that there can be a larger representation of views or perspective from males. So my descriptive analytics should not just be something that is completely disconnected from my main model that I'm using in the data, but it is actually connected because it's giving information building up to the model that I'm going to run. So descriptive analytics, we normally use it sometimes even when we run research studies. So we are trying to understand the data and its patterns and so forth. Then we have diagnostic analytics, where we want to understand why something happened. I remember in 2021, I was working with a colleague with a colleague on a research study. You remember it was the days of COVID. So the idea was, let's do a study on analyzing how certain demographic factors influence COVID based on observations on what was happening, such as you'd observe that we had issues of social distancing, which actually implied to say that if there is density among individuals, COVID is likely going to spread a little bit faster. So we said, let's collect data on recorded COVID cases, and then we extract demographic data of certain maybe wards or municipalities in KZN. And then we try to see, what happens. So what we're trying to do is COVID is there, and this is what is happening. We want to see what factors are mostly sort of predicting it. And we can also write a recommendation to what can be done. So we went to different websites. I think she had access to data on COVID, and she downloaded that. And then we had to go to different sites. I remember one of the sites was this one called Wazi Maps that collects sort of different data on various municipalities across KZN. So we're collecting data on your socioeconomic status, data on population density, data on unemployment, and sort of collapsing it to various forms of unemployment, like your youth unemployment, your adult unemployment, and so forth. And then we use a Bayesian approach to say there's a lot of variables in the data. How quickly can we reduce them to focus on the most important one? So we use a method called BAT, Bayesian Additive Regression Tree Models. So to run decision trees and see which variables are mostly contributing towards explaining COVID incidents. So after doing that, we noticed that what we expected to say where there is population density, COVID incidents supposed to be higher, or maybe people with low socioeconomic status are most likely going to be grouped in areas that have high population densities. Some of our assumptions did not hold. And then we had to investigate interactions among the data and found that some variables that were not significant as individuals or by themselves in the data were actually significant when they were interacting with another variable. So we were able to try to understand what is happening. And I think we wrote a paper that is there online. It's called Spatial Patterns of COVID, something like that. Then there's the issue of predictive analytics, where we want to use historical data to build a model to predict patterns that we're likely going to observe in the future. For example, the study I was talking about earlier on bank-specific factors, we wanted to understand the performance or the future performance of large banks versus your medium-sized banks. So we wanted to investigate what the relationship had been in the last 20 years or in the last 10 or 20 years, and then use what we are finding to predict what the future is likely going to be. Although there was a little bit of challenges, we wanted to use specific methods that were not fitting the data, and then we have to go back to the data again and try to use another method. And we also had to find out that a more simpler model is always better than a more complex one. When you add a lot of variables, while a simpler model is likely going to capture little variation, it's better to understand little variation than a model that is not likely going to be an accurate representation of the future. So there is also the issue of predictive analytics. And then we have prescriptive analytics, where we actually run data analysis in order to prescribe what should be done, which is what probably we mostly do when we are researching within our various departments. We want to see exactly what is happening to be able to see what can we prescribe, what new methods or innovations can we put in place to make sure that we sort of improve how things are in the future. Right, then I want to talk about data structures. So with data structures, we're talking about the ways in which the data we use for analysis is organized. So in Stata, we talk about data sets. They can come in various forms, like it can be an Excel, can be a CSV file, it can be data that you export from other formats like your JSON and so forth. In R, we talk about data frames. It's exactly one and same things, just different, maybe concepts. So most of the data we deal with is two-dimensional tabular data structure, where you have your rows or cases, and then you have your columns or variables or the features of the data. And the columns can be measured, either they can be numerics, or they can be character variables, or they can be factor. You know, character variables is like, in Stata, they're called strings, or is your basic names and so forth, on which you cannot do any analysis, which means it needs to be transformed to either a factor that is unique levels, which you can use to categorize the data. Then we have also time series data. That is basically you're following a specific observation based on time. I think this is the kind of data you find when you go to websites such as your World Bank, and you're collecting data from world development indicators, and maybe you're looking at labor force participation of countries across over time. You'll notice that it always gives you a time index. It always gives you sometimes also an ID of the specific country, and then the particular metric you're looking at, which is a characteristic also of panel data or longitudinal data. So it's also something that we want to think about, given the model that we want to use. For instance, you cannot use a panel data model on a data set that doesn't have a time and ID variable. So knowing the structure of the data helps us to think about how we need to prepare our data if we want to perform modeling on it. Then we have the issue of measurement scales. As I said earlier, that when you look at the features or the columns, the data contained is measured at different scales. It can be numeric, it can be character, or it can be factor. So these are the known data measurement scales. I'm sure you've all come across them. At the minimum or at the lowest level is your nominal scale. For example, how we measure gender, education level, marital status, or any other, when we sort of arbitrarily recode, let's say, a continuous variable to include categories, there is no order, there's no sort of value in the numbers that are attached to the labels. Like, for example, if you say primary education is 1, secondary is 2, tertiary is 3, there is no importance in the labels, the numbers, they are just identifiers. However, the nominal scale itself, those categories, we say they are mutually exclusive in the sense that they do not overlap. And also the categories are unordered. You can always choose which category you want to be first based on maybe how you want to investigate that particular variable in your analysis. So the type of descriptive analysis we use when you're looking at nominally scaled data could be your calculation of frequencies. Maybe you want to do bar charts or sometimes pie charts to just want to see the distribution. And we want to observe what is the most occurring, maybe category, and so forth. However, with data structure transformation, you can be able to do other forms of analysis. For instance, I can take my education level variable and say that I want to convert each and every category into a binary variable, right? And then I take another another nominally scaled variable as well, say marital status, and also transform it to a binary structured sort of variable. And then I can run correlation analysis to see how are various levels of education related to different categories of marital status. But I have to transform the data before I can do that. Then secondly, we have ordinal scale data where there is an ordering in the categories. You have used this mostly when you are using Likert scale data. You're using a Likert scale when you're collecting data, which is increasingly how we're collecting data due to the difficulties of accurately capturing some particular aspect. Let's say you want to ask people's income levels, or there is a certain aspect you want to measure that cannot be captured by a single metric. So you ask a number of questions, asking people to say, can you rate on this particular scale? So you notice that most of the studies we use, even data that we use mostly in the department at teaching and learning unit, most of it we use Likert scale to measure it. So when you take a Likert scale data, the numbers, yes, have an ordering. It can be strongly disagree from 5, going all the way to strongly agree. That is 1. If you have to calculate the mean of that data, it doesn't make sense, right? So there are other things, although, that you can try to understand, okay, what was the median sort of response when people were basically tabulating their preferences? What was the median? Or you can calculate the interquartile range, but they might not be as meaningful unless you actually transform the data. Maybe you want to analyze correlations, like when you use correlations, or you want to reduce dimension. When you use factor analysis, you want to actually make sense of that particular data. So there's ordinal scale data, which we are using, particularly in survey data, because it sort of accurately measures phenomena of interest. Then we have interval scale data, where data is ordered in intervals which are meaningful, but the zero value is not necessarily true. For example, when you are looking at temperature, I think it's the most common interval scale data, temperature measured in degrees Celsius. The 0 is not necessarily true, as what the 0 actually means when you're looking at the real number scale. Then we have your ratio scale data, where the data has properties of an interval scale. However, the 0 point is meaningful because it actually tells you whether sometimes your data is correct or it's wrong. Imagine you are collecting data on height and you find a height of 0.0. That actually tells you that there's a problem, because there cannot be a height from your sort of background knowledge. There cannot be a height of what? Of 0. So the 0 value is meaningful, and variables that I can think of include your height, weight, length, income, and so forth. Income measured at the continuous level. We can perform various descriptive statistics on it, including your calculation of the mean, the standard deviation, calculating ratios, as well as comparisons. So whenever we are collecting data and we are preparing to run analysis, we need to think about the way the data is going to be measured, because this determines the kind of methods we are going to incorporate in actually modeling that data. So sometimes you find that a person says, my study is a descriptive correlational study, and the entire data is based on categorical variables, and the method that they are proposing are all methods that are suited towards continuous level data. So these are very simple but foundational concepts that we need to think about whenever we are collecting data or looking for data, or even thinking about carrying out our research. Then the last aspect I want to talk about is data modeling approaches. So as we said when we started, that data analytics is a systematic process. So when we are looking at data, most of the all the methods we use, they fall into a particular sort of framework or approach to modeling. We might not think about it, but it exists. We should guide the way in which we collect data, we prepare data, and how we model the relationships in the data. So there's a number of data modeling approaches. I decided to take 4 that are very popular, which we use one or the other in our research studies. So there's the conceptual model approach. Then there's the theoretical model approach, the observational model approach, and the empirical model approach. So sometimes you see people writing on their papers an empirical analysis. So it'll be good to get a sense of the various approaches that exist to data modeling, so that when we are thinking about our data, we are going to be thinking about what approach am I actually using that will also be useful in how we design our studies. So I'm going to be using examples. Unfortunately, I wasn't able to. I thought it would be good to then include that when you're actually doing hands-on. I wasn't able to include extracts from some of these studies that we have done. You can actually see the analysis, what it looks like. I didn't want the slides to be too long, but as we will be doing our demonstrations, we'll be going into looking at the actual analysis, how it's done. So I'm likely going to be sharing with you some of the studies based on my knowledge. So when you look at the conceptual modeling approach, when the researcher is using this approach in the data, they create an abstract representation of the structure and relationships in the data. So mostly you're looking at entities. What are we talking about when we talk about entities? These are the things we want to measure. Let's say you want to investigate maybe marketing strategies. Like, for example, a recent study we did on brand awareness, where we're trying to understand brand awareness among customers who are doing online shopping. So the entities we wanted there were the various brands. We also wanted the customers themselves, and we also wanted their geographic locations and sort of. So we want to investigate the entities. And on each entity, we look at your attributes. So a customer is of a particular age, a particular category of income. They can be residing in a specific geographical area, or they can be from a particular population group. They can have a certain educational level. These are called the attributes of the entity. And then we also think about the interactions among the various entities in the data. How does geographic location influence a particular customer's behavior towards a particular brand? So we often use this approach in designing databases, mostly information systems. We want to ensure that the model we're designing, it actually fits a real world scenario. So the approach to modeling, when you are using a conceptual modeling approach, it focuses on identifying the data used. The model is focused on identifying the data. So we are identifying the entities so that we can just collect data, but we're not actually thinking about the flow of data collection. We're not trying to control that. We're just trying to identify the entities and sort of collect data on the various characteristics of the entities and their attributes, as well as the likely interactions among those entities. So a case study, in a recent study, which we're using structural equation modeling, we're analyzing entrepreneurial intentions among small-scale farmers in KwaZulu-Natal, use the theory of plant behavior. So we wanted to understand what are the determinants of entrepreneurial orientations or endeavor among these small-scale farmers within the context of the theory of plant behavior. So the theory of plant behavior has constructs that is the attitude towards the behavior. In this case, engagement in entrepreneurial activity. We look at various aspects of a person from their risk profile. Are they more tolerant towards risk, or they are risk averse? We look at maybe their general attitude towards how they see their current activities. So we look at attitude towards the behavior. Then we look at subjective norms. What are the prevailing influential sort of attributes that may influence or dissuade someone from a particular action? Like these days, when you go maybe online, you notice that there's a lot of, you can't rely on your job. You have to be doing something, right? So people try various things. So there's a whole lot of social pressure trying to motivate a person to do something. So we can think about that as subjective norms, as well as perceived behavioral control. That is the capabilities of the perceived capabilities. Someone can say, I don't think I have the knowledge, or self-efficacy. And then the goal was to model how these constructs and other demographic factors predict entrepreneurial intentions of the farmers. So the entities we identified from a conceptual modeling approach were the farmers themselves, the entrepreneurial intentions as outcome variables, then the constructs of the theory of plant behavior, as well as various other demographic variables such as your age, gender, spatial location, farm size, educational levels, and so forth. Okay. So the next thing we did was to sort of define the relationships. Like I was saying earlier, that the farmer has attributes, and then the theory of plant behavior, it sort of predicts, or it tells us that there's a certain relationships among its constructs. And the attributes there, when we were measuring for the farmer, we took the farmer's ID, the age, gender, education levels, and farm size. Then we calculated scores of the theory of plant behavior constructs. So we collected data using a survey, and we measured it using a Likert scale. And then we use factor analysis in this case to calculate scores. So we calculate the attitude score, we calculate the score on subjective norms, we calculate scores on perceived norms, and then we use these scores as predicting variables in the model. And we also calculated the entrepreneurial intention score. So one of the usefulness of thinking about data from a conceptual modeling approach is when you have a very strong conceptual model, you are able to structure your data collection in how you define your questionnaires and how you directly also measure the constructs. So the approach informs the kind of data, how you're going to collect the data, and how you're going to actually use the data in the modeling step. So the conceptual model, it guides the analysis phase, ensuring that the hypotheses derived from the theory of plant behavior are testable. The theory also guides the structure and relationship between entities and their respective outcomes. So this is one of the ways we think about it. I think we mostly use a conceptual approach without actually thinking much about it. Sometimes you hear students saying that my research study or my chapter was returned because the professor wants a conceptual model. And they have no idea what they are going to do. So you notice that this actually helps you to think holistically about the entire study, the concepts, as well as the relationships and the kind of data, even how you are going to provide reliability measurements, as well as validation of the kind of modeling approach that you used in the study. Then we have the theoretical model. This is very popular. Normally, we use it when we want to take an established theoretical model and apply it in a research area of interest. Common theoretical frameworks I've worked with recently include the technology acceptance model. It's another version of it called the UTALT, as well as the technology organization and environmental framework. We're using this one to investigate broadband internet adoption among SMEs in Nesprit. So the model is grounded in theory, and the theory itself defines how the different variables interact and what patterns or structure can be expected from the data. So the theoretical modeling phase, it involves constructing abstract representations of data and their relationships based on the theoretical hypothesis. What are the key characteristics of the theoretical modeling approach? The first one is that the approach is grounded in theory. Theory informs everything from the nature of the data, the kind of relationship that are expected. Mostly, we use this model when you're actually testing whether we can use a particular theory within another context. And there's abstract representation, when we are looking at the higher level relationship that exists among the variables and not necessarily the concrete implementation details, then the model itself also is largely hypothesis driven. So you have to come up with a range of hypotheses that informs how data should be collected, how it should be organized and analyzed, because you are testing those particular hypotheses. It also has directional or causal relationships. One variable or more variables are expected to influence other variables. Then we talk about the issue of validation and refinement, that once we've constructed the model, the theoretical model itself has specific metrics that we test empirically. And we also, after finding the results, we can then go back to see how can we best improve or make recommendations towards adjusting the theory or making theoretical contributions. So the validation and refinement phase becomes an iterative approach. So we use the theoretical model. Sorry, I think I skipped a page. Right, so we use the theoretical model in this is an ongoing study, so please don't steal my study. So it's so we're investigating social exclusion and economic participation in South Africa. One of the concerns is that when you look at most of the data we have, we collect it with a lag. If you look at census data, we collect it after every 5 years, and we take time to actually process the data before it's available to the public. We have other also excellent data sets like your National Incomes Dynamic Study. You can find it on DataFirst website. It's good data. It's collected almost every 2 years, I think until 2017. But every time the data comes after it has been collected, which means by the time we are analyzing it, maybe a whole lot of things would have changed in the environment of interest. Currently, we are living in the era of digital transformation, and I think we are seeing the effects of digital transformation. Some are not yet understood, like, for example, the high levels of unemployment currently in South Africa. One of the explanations is digital transformation, which is just making some jobs to be automated, particularly your lower skilled jobs and so forth. So the motivation was, can we try to look at data that is produced almost every day? Like these days, when you look at your phones, when you walk, they tell you exactly how many steps you have walked in a particular day. You can collect data on your heart rate and so forth. So we're saying that there's increasingly all this data that is in the public domain. Why can't we develop a new metric that can help us to measure how digital transformation is actually leading to social exclusion? But part of the study, obviously, is to go back to want to use the data that actually exists so that we can then use that to pattern how we can develop the new metric. So the research context, I'm trying to investigate how social exclusion factors such as your lack of access to education, unemployment, and discrimination influence economic participation, which is measured through income levels, employment status, or entrepreneurial activity. So the possible theories I am using is the structuration theory by Anthony Giddens and the innovation systems theory. So the structuration theory simply focuses on structural factors of the society, things like your social norms, education systems, your labor market structures and policies, as well as things such as the individual agency, focusing on a person's likely engagement in entrepreneurship or their job-seeking behaviors and so forth. So the key concepts when you are using this approach, it's grounded in theory, and then the theoretical components of the structuration theory, which is the theory that is informing the study. You are looking at the social structures, as I said, educational systems and labor market policies. And then you also look at agency, such as the individual level factors, entrepreneurial efforts. And we also look at outcomes such as your economic participation, which we measure by employment status, income levels, and an entrepreneurial success. sorry. Right, then we came up with a number of hypotheses that are actually informing the relationships we want to model from the data. So access to education influences economic participation. High levels of social exclusion may be multiple forms of discrimination or unemployment are negatively correlated with entrepreneurial activity. Then we also assume that government policies and labor market conditions are likely going to moderate the relationship between social exclusion and economic participation. So the data requirements here, there are multiple options. We can run a survey. There's also the National Incomes Dynamic Study, the quarterly labor force survey, or census data that is available. Obviously, there's the basic steps of data analytics, preparing the data, cleaning it, transforming it, and then preparing the data for the particular analysis. The relationships are there that we're assuming. Education predicts job-seeking behavior as well as employment status, discrimination, access to resources, and entrepreneurial activity, as well as the mediating or moderating role of sorry, what's happening now? The moderating role of government policies. Then model testing and data modeling, we're using structural equation modeling. So what I'm trying to demonstrate is you would notice that taking the theoretical approach, we are mostly using the propositions of the theory itself to inform the entire process, and even the methodological approach we then use to model the data has to accommodate the various relationships that are sort of proposed by the theory itself. So when you look at, for example, structural equation model, before you can even begin to interpret the results of the structural model, it tests whether your data is an accurate fit. The data you collected does it actually or accurately fits the particular model that you're choosing? So you'll notice that there are metrics that are associated with structural equation modeling. Some of them, such as your comparative fit index, your Tucker-Lewis index, your model chi-square, your root mean square error of approximation, and so forth. All they do is try to give you a sense of how your data actually fits the model. So when you just collect data without thinking about the theoretical approach, and then you want to implement a structural equation modeling, you run the risk of finding that the validation of the model itself actually tells that the data does not actually fit the theory. And this is something that I've observed in many research studies that I've had a chance of. Somebody says, please, can you help me look at my study? You notice that the data that was used does not actually fit the model. And just because now there is a month or a few weeks before submission, they want you to try to do whatever you can do, which actually results in a master study that is of no practical usefulness. So these modeling approaches are useful. We need to think about them when we think about data analytics. It's not something that we can then say, no, I'll think about it at a later part of my study, but it's actually a more holistic approach of actually thinking about the entire research process.
Sorry.
I'm almost done, then I was gonna open, for questions and So obviously model refinement and validation, where we test the model on empirical data, and then we also refine the theoretical model based on the findings. Right, lastly, there is the observational. I'm saying lastly because the empirical one, it sort of uses the same concepts as the observational approach, but it mostly focuses on large data sets that are collected when sort of, you can say, without manipulation in their naturally occurring form. So you can think about health records, you can think about economic data, and then we want to investigate the data to build a model that is grounded in the data itself, and then use that model to predict what the future is likely going to be. So the last one I want to focus on is the observational modeling approach. So in this approach, learning occurs indirectly. You're observing others, or you're observing a particular phenomena, and then you are modeling it. In this case, they say imitating. I think you can think about what was proposed in the social learning theory by Albert Bandura, when it talks about how learning occurs through modeling. Then, so the data modeling focuses on describing and analyzing the patterns without making any assumptions. So you take data naturally as it occurs, you model relationships, maybe you're looking at correlations, you're reducing dimension to see how the particular features of the data are grouped together. So it's a very useful approach when there is limited prior knowledge, or maybe the underlying mechanisms of the data are too complex to model using a theory. So you would rather test the features, look for, in these days, we have modeling approaches such as your machine learning and data mining methods, where you sort of get a little more detailed insight into the data before you actually start developing your model or developing specific hypotheses. So the key characteristics is descriptive, it's data-driven. It's also exploratory in nature, in the sense that you want to understand the patterns that are in the data. It's also model agnostic in the sense that it does not assume any sort of statistical model until you observe the the relationships or the patterns in the data, and you decide on a model that seems to be fitting. You don't manipulate the variables in any particular way. Mostly focuses on real world data. So we can think about your census data or some other large scale data sets that are publicly available. Some of the analysis methods, as I said, is correlational analysis. These studies, they tend to have a high level of external validity because you are using real world data. So what are the... My computer is starting. Okay, fine. Yeah, so what are the use cases of this particular approach? Normally, when you're doing exploratory data analysis, which we'll be demonstrating, we're mostly just taking data. We're not making any assumptions. So we want to understand the characteristics and distribution of the data. We want to identify, the values of the data, how they whether they are outliers, that is large values in any particular distribution, and to be able to think what could be the explanation behind, the explanations behind these large and unusual observations in the data, and also discovering potential relationships or patterns. Then, based on the patterns, we would also want to generate specific hypotheses. So you notice that you first you first analyze the data looking for patterns, and then your hypothesis generation comes a little bit later. So observational modeling approach accommodates that. Also for predictive modeling, if we investigate the structure of the data to find the patterns, we're able to then determine which features are likely to influence and what outcomes we can expect. Then also anomaly detection, that is when we want to identify unusual patterns in the data or unexpected data points, so that we can begin to think maybe about the data based on whether we want to focus a little bit more on those points or want to focus a little bit less on them and on the majority of the data based on the findings and the distribution of the data. Right, so these are I think the foundational principles that underlie data analytics when we are thinking of it. So we want to think about the particular form of data analytic that we want to use whenever we are undertaking research, whether are we thinking at a descriptive level, or are we thinking from an inferential level? We want to use our sample to make predictions of the population. That informs how you collect your data, how you design your sample. Also, the various approaches that we investigated here, like from your conceptual to your theoretical, your observational, as well as your empirical approaches, we normally use these approaches without actually thinking about what we are doing. And at some point, we run into difficulties because the data is not seemingly fitting what we are likely going to expect. So these are the principles that underlie data analytics. And as we'll be modeling and learning how to use software to analyze data, we need to be thinking in terms of these principles, how we measure the data, how the data is structured, the kind of models that we want to use, and how we can transform our data to ensure that it fits the specific assumptions of the model or the modeling approach that we want to use. Thank you.
Yes, we'll open for questions.
Hi.
Yes.
Thanks a lot for the presentation. I've got two questions.
Yes.
The first one is to do with study design. So you spoke about the concept of frameworks and them being needed, and the sort of the issue with when you're doing masters like myself is that you normally read papers, and then those are mostly results papers, not like the process. And so you see there's a nice conceptual framework kind of a thing there, and then you're like, oh yeah, but then is that, and then it usually sits there at the beginning and kind of thing. And so in your mind, you're thinking, in my thesis development, to start with that, or is that what you report after observing your data and analyzing your data? Then you can sort of like see a developing concept. Then you kind of like report on that. Is that a step that happens when you are designing, or is that something that happens after your data analysis? The second question,
yes,
if you don't mind.
Yeah.
So looking at your conceptual modeling and observational modeling, I see some sort of like similar patterns to it. So the question is whether, when you've decided which one you're going to use between the two or whatever, is it possible to use both at certain points of your study, depending on your objectives?
Okay, yeah. So I think on the first question, Professor is going to cover a lot on that in a presentation. But I can say that from my limited knowledge, I can say when you look at a paper and you see a conceptual model and you import it to your study right away, I think that is a very wrong approach. We're looking at a conceptual model should help you to try to go and read a little bit behind what is the theory behind designing this particular model. And then you can then reasonably sort of maybe it's good to borrow concepts. Yeah, and you can reasonably then borrow the concepts after having a deeper understanding on how the conceptual model was developed in the first place.
So my question is not whether I can borrow it.
Yeah.
The question is, when in my study do I construct, or do I decide on what concept it's going to happen? Does it happen before I do data analytics, or is it something that sort of unravels as I do my data analytics?
I will cover that in detail in my presentation.
Thanks.
But just a quick before before you do data analytics, because it's, yeah, I see a hand.
It should be in the proposal stage of the model.
In the proposal stage of a master's, yes. Yeah, because you are actually trying to communicate what is it that you want to investigate, the relationships, and they should be informed by those concepts. In the second question, why have I suddenly forgotten it? Can you?
No, I was just looking at.
Oh, yes, sorry. Conceptual and observational approaching mode. You'll notice that the conceptual concepts are based on relationship that are established in theories, whereas the observational approach does not have any prior assumptions. You are taking data and you're investigating patterns. Can you integrate the two in a particular study? I think it's possible to integrate the two. I think it's possible to integrate the two in a study. I'm also sure about probably there are more experienced people in this room who also have, been doing research for quite some time. They could be even more knowledgeable, but I think there's no challenges in integrating the two, but they are distinct in the fact that one uses assumptions, the other one doesn't take any assumption. The assumption in the conceptual model is in the very concepts themselves. To say these concepts, they've been derived based on this theory and may mean this. Yeah. Yes.
Main difference between the conceptual framework and the theoretical framework.
So the key difference between a conceptual framework and a theoretical framework. So the theoretical framework, we are looking at the abstract propositions of a theory. So for instance, you're looking at the theory of plant behavior, and it has specific propositions that it makes concerning the relationship that exists in its constructs. Now, when we're looking at a conceptual model, we are then taking the theory and we are looking at its core concepts and we're trying to operationalize them in our specific research. Yeah.
Maybe if I can also add to that is a conceptual framework helps us in terms of, for instance, it helps to identify what you want to study. Let's say I'm studying poverty, right? I have a conceptual framework of what are the poverty indicators. A theoretical framework would then help me answer why, right? Like for instance, why is education maybe one of the variables that I need to consider in studying poverty. So that's how they sort of like work together. And you find that in different disciplines, you might use them differently, right? But, and you find that in more quantitative disciplines, yes, you might have a theoretical framework, but eventually you need to sort of like develop that theoretical framework into a conceptual framework, because you need to use the theoretical framework to identify what variables do I include in my model. So theoretical framework answers why, conceptual framework answers what. I don't know if that is clear. Is it enough?
Yes.
Presentation. I want to ask, in the section for hands-on, is there a particular app you need to install?
Yes. Oh, yeah. I should have discussed that. We are going to be using the Stata software. I think at UKZN you can download it from the software repository, the student software repository. We're going to use the Stata software. Another one that we are going to just introduce but not use today is the R software. So if you can also download that one. The reason for not using it extensively, we only have 2 days, and R is a little bit complex due to the need for using multiple modules, but we are preparing a subsequent workshop very soon where we will actually dedicate to use of R, for the simple reason that R is free and it's open source, whereas Stata, yeah, for some of us, we are lucky that we're at university. If you're not at university, it's very expensive to just buy the license or even to access it. So that kind of limits how we can apply it in our research and so on. It's just R. Yeah. Yeah.
I also ask, in a quantitative study, using either a theoretical framework or a conceptual framework, must there be a hypothesis?
That one.
Yes, in a theoretical, according to the theoretical modeling approach, from when you are using the theoretical modeling approach, hypotheses are needed. Because the approach itself, it assumes that the theory that underlies the study, it has specific hypotheses that should be made that connects maybe constructs or variables together. In a conceptual model, I think they are assumptions. They can be assumptions or explicit hypotheses that you state, but they are assumptions regarding the relationships that exist among the variables that you are looking at in your study.
relational
Even with, yes, correlation comes as a statistical method. You can use it either in a conceptual model or in a conceptual modeling approach or in a theoretical modeling approach, because you just want to understand maybe the relationships among variables and stuff. Yeah.
There's a presentation. What did you duplicate?
I just think this is like one of the questions you be taking.
Can you show me? Since we had tea in the morning, I think we can just continue. The plan was for us to have a tea break, maybe 15-minute break. But if you want some tea, I think you can always just walk out and get your tea. While we continue, hopefully we should be able to finish this session by 12:30. Right, so that we can have lunch, come back at 1, and then do the next session, which is more hands-on and practical. Okay, so I'm going to focus on research designs, and some of my assumptions that I had was that everyone here has some foundational knowledge. So it's not like we're talking to people who have never done research. We've done research of some sort, right? So we have some foundational knowledge, some even more advanced knowledge as well, right? And it could be advanced knowledge in a particular method, in a particular design, right? So that's my first assumption. The second one is that people here are interested in research designs, right? I think I've already had a question there on research designs. That we have diverse expertise. Some of you come from, different disciplines. I see colleagues from the College of Health Sciences here as well. We've got different, expertise, but we are interested, that was my assumption, in research related to teaching and learning. And when I'm saying teaching and learning, I'm looking at an academic in a class, thinking about how can I better improve my practice and what data can I use to improve my practice. And I know some might not necessarily be interested in teaching and learning related research questions, but however, the principles that we are going to discuss here, they do apply to almost every research. However, a lot of the examples that I'm going to personally provide are examples related to teaching and learning. You're also curious about data analytics and you're interested in practical applications. Okay, often when we do data analytics workshops, we focus on software. And I'm pretty sure, maybe can I see by raise of hands, how many came here like really just wanting to learn how to use data, SPSS? Can I see by raise of hands? Exactly. Most people, that's what we want. But however, I'm going to say this. Statistics or doing data analysis, you need to understand the philosophy behind it, right? Because when you get statistical software, garbage in, garbage out, whatever you input there, you're going to get results. And if you cannot, just by looking at your results, as an experienced researcher, sometimes I just look at output and I'm like, no, something is wrong here. I need to investigate. But if you don't have that understanding, you accept everything. Most of us here, we use statisticians, right? And when we design our studies, the statistician was not there. We give him our research questions, do whatever method, they'll give you an output because his job is to get paid, right? But you've got a study that has limited validity because maybe the methods that were used to analyze are not appropriate for that particular study. So because of that, I want us to start, by just looking at research design. I'm not going to really bore you, maybe a little bit with what is a research design and so on, but I want us to talk about some of the misconceptions that we have about research designs and also talk about how we can actually better approach the concept of research design. Okay, so what foundational knowledge do you need before being introduced to statistical software? Anyone who tells you that they can run a workshop on data analysis without you understanding these issues, that person is lying to you, right? So you need to understand what are types of data, right? You need to know that nominal, scale data and so on. You need to know about data cleaning and preparation. In fact, personally, from my personal experience, I always find that data cleaning takes more than 50% of the time that I use analyzing anything. Because that's if your data is not well prepared, believe you me, you're going to struggle. I actually take more time cleaning the data. That's where the challenge is. You're not going to find data that's already clean and ready to analyze. Most of the time, you're going to find data that has got a lot of errors, missing values, and so on. So you need to know how to clean data and how to prepare it for analysis. That's one of the things that we're going to focus on. You need to know about data structures as well, because this statistical software, they work with certain data structures. You need to know about basic research design principles and some basic statistical, at least know about measures of central tendency before you go for a workshop on how to use theta or SPSS. Know what mean, mode mean, right? You need to know at least just some of these basic things. Ideally, you also need to know inferential statistics, right? And what do we mean by inferential statistics? Inferential, with your descriptive, you're mainly looking at your mean mode. Inferential, now we are saying, we are now using statistics to infer. That's where we now use advanced methodologies, like you said, your regression models, your machine learning, and so on. You need to at least have a bit of understanding on some data analysis techniques, and you need interpretation to know how do I interpret when I'm given these results, how do I interpret them? Often students will go to a statistician, the statistician does the analysis, they don't even know how to interpret the analysis. And sometimes the supervisor also doesn't know how to interpret the analysis. And when you read the thesis, you're like, a lot is actually left out of this analysis. So it's very important that before you learn how to use software, you actually know how to do these things.
I don't know what it's just highlighted on this slide. Asked you the honest truth. I attend Statistics 101 lectures because I'm not registered. Is it allowed that I learn all of it? I'm assuming Statistics 101 is the basic foundation of all of them.
So here's the thing. It will depend. So first of all, you have to register, you have to pay. So you can't just walk into a classroom and say, I'm here to sit. You have to pay. So you have to register NDP, non-degree purposes. Secondly, it depends on at what level it's pitched. So if it's Statistics 101, pitched for the School of Statistics, I bet if you have no foundational, you're most likely going to struggle with that, right? Because remember, statistics it's also maths to a certain extent. So you need to have a certain level in understanding of mathematics. I would advise that you probably do statistics for dummies, if I may put it that way. There are a lot of MOOCs online where you can actually access some of these things. They will take it at your own pace. You do it at your own pace, without having to actually sit for a MOOC. But if your maths is good, right, then you can go for Statistics 101. But if you're coming from a very much non-mathematical background, I would suggest you do something that takes you at your own pace, right? So at least you know. In fact, it's very important that you know what your statistician is going to give you, right? Because remember, he was not there when you were designing your study. So he does not even understand the thinking that went into designing that study, what you were hoping to achieve. All he knows is how to calculate, certain statistics. All he knows is how to input it and how to interpret it, but it might not be exactly what you want. And maybe I should say this as well. It's also very important that you know and understand your own data, right? Even before you export it to any statistical software, understand it. Now in this data, I've got how many missing values. You need to know all of that, how the data is structured, know it. Such that even if you don't have a high level understanding of statistics, at least when you get results, you can say, but okay, where did this values go, because I had 1,500, now I'm seeing 1,200. You get it? So it's very important that you at least know your data. These are things that you can do in Excel, for instance, if you are dealing with quantitative data. Okay. So I love cartoons. Even in my PhD, almost every chapter started with a cartoon that actually explains, I always see writing a dissertation as telling a story, right? You tell the story from the introduction to the end. And I love using cartoons as well, because they sort of like explain, maybe in a better way and in a humorous way what, you're trying to accomplish. So here I've got this cartoon. My team has created a very innovative solution, but we are still looking for a problem to go with it. This is how most of us approach our research, because sometimes someone comes to you, you already have the answers. You already have the answers. And the question is, if you have the answers, then what are you researching? Because research is not just about writing a dissertation or writing a research paper, right? It's about answering questions. So what does this mean for research design? First of all, I want to say that, let me see if I can move this, because, okay, I don't know what I did now. Where's Pumla? Okay. Oh, okay. I don't know whether it's.
Let me just go.
Okay. This one. Oh, okay. All right. I was trying to move this thing because it's disturbing me. How do I move this? I need to move this. Presentation is same. Can you move it maybe to the corner or somewhere? All right, that's better. Okay, so often when we do teach in research design classes, we teach research design as a linear process. You start with your research idea, literature review, formulate a research question, and so on until you finish your study. However, in real practice, research design is not a linear process, right? It requires you revisiting the problem throughout the study. I heard someone talking about the conceptual framework and the theoretical framework. Sometimes you might even need to revisit your study, your theoretical framework in the middle of your study, right? There's nothing that says you must stick to your theoretical framework until you finish your study. You don't force your theoretical framework to fit your data, right? So sometimes you might need to revisit it. However, if your theoretical or if your research is well designed from the onset, you're most likely not to experience those problems because you've already thought about all the challenges that you might experience, right? So research is actually a recursive process and is overlapping, and at times it can be a messy process. Right. So don't look at it as if it's something that is just linear. You start with your research idea, you stick with it as it is until the end. Sometimes it doesn't happen like that. But if it does happen like that, then good for you. And also, it also says you need to actually think about what could be some of the challenges that I might experience in doing this kind of research. What kinds of data am I looking to actually maybe get or collect? Another thing is that most people think research design is very simple, right? I just come up with an idea and, I decide I'm going to use this particular design, I'm going to use these methods, and that's it. In real practice, you find that there are a lot of questions that you have to keep on asking yourself throughout your study. So there's a difference between doing research because you want to get your degree or you want to publish, and doing research with real world applications, doing research which is meaningful, right? Okay, so how do you define a clear and relevant problem? In fact, how do you identify a clear and relevant problem? How did you identify in whatever studies that you were doing? How did you identify that this is really a problem and I need to investigate it? After thinking about, okay, yes?
Problem in
You can do that. You observe the problem. That is true. And
someone saying there is no problem, just create a problem.
maybe you could do that. Maybe just create a problem. It does work. And here's the thing, you could do that, because sometimes you're just trying to disrupt, right? And I think I'll talk about that a little bit later, right? And yes.
Probably you could also look at the gap in literature.
The gap in literature, right? So for you to come up with a good research question, you need to do prior research, right? You can't just think that I need to do this and already you run with it. So you need to do, if you're a practitioner, maybe you could actually see a problem, right? I am a medical doctor, I am a nurse or whatever. I see a problem in my practice, right? And I need to investigate that. But most of us, we don't have, that advantage of like really dealing with real world, real life problems on a daily basis. So you need to do your research, right? You need to do, yes?
In a case where you are just curious, for instance, you know that there's a treatment system that has just been implemented. So how do you find the problem in the sense that you want to research for that? Because I was curious to find maybe what the treatment system have, what financial implications would it have into the financial security of. Okay, let me rephrase my question. So the support system that's been implemented, I'm trying to find how that is going to affect the financial security of the South Africans in the future. So how do you go about finding that? Where's the problem?
Okay, so before I answer you, I'm just going to maybe pose another question to you. If you have been, I think, maybe following what has been happening, a lot of these retirement fund companies, they've been actually having workshops, right? And one of the things that they've been clearly addressing is that issue of how, if you withdraw from your own fund, how it will affect your future savings, right? So how does what you're saying now fit into that? Has that question already been answered? Is there anything that is still lacking from what they've been saying? You get it? So you still need to actually find out what is actually happening, what is being said before you actually come up with your own research questions. So it's very important that you do play some preliminary research. It could be just scanning the literature, right? And if you do it well, I personally, right now, I now have 3 articles that I never intended them to be articles. based on just a careful scan of the literature. And then you realize I've done a good job in actually scanning this field. So why waste this? You know, I was doing it just to understand the field, but now I actually have a lot of data. Why not convert it into an article, right? Because there are actually journals that accept reviews. So do a scan of the literature. I'm not saying you need to do it as thorough as I have done, because once you do it that way, there are also certain methodologies that you have to follow. But just do a scan, know exactly what are the gaps, what is being said. In fact, good research is about asking yourself, why would people care about my research? Right? Why would we care about your research? It's not about how interesting it is to you, but do we care? Who cares about that research? So it's about answering that why. And if you can answer that why, then you've got a very good research question. And when you've thought about your clear and relevant problem, then you need to think about what methodologies best align with your research questions, right? You don't think about methodologies at a later stage. Methodologies, you think about them because they are going to determine as well how you design your entire study. They're going to determine your instruments. They're going to determine your data sources. They're going to determine a lot. So if you don't think about your methodology and you just think about it when you now have your data, you see how it can be actually problematic, because you might have data which does not really answer your research questions. So think about the methodologies. But remember, like I said, your research is actually an iterative process. You're going to have to go back and forth depending on, for instance, let's say you want to use research on, my daughter was doing research on TB, right? And her understanding was she would get all this data in one portal, right? But when she got the data, she realized that there was a lot that was missing. You get it? Unfortunately, she couldn't access that data at the beginning because she had to get all the clearance. So she had to submit her proposal, right? Without knowing what exactly is in that data. When she got it, there was so much that was missing. So she had to go back to a research center and say, how do I refine it? Because there's no way she's going to create new data. That's what she already has. So it's going to be a very iterative process. And how can you ensure that your findings will make a difference in real world context? That's what we should be aiming for. What are the implications of our findings? And that goes back to my question, who cares about it? Because once you identify who cares about it, then you have implications of your findings in a real world setting. So what are some of the key elements of research design? This one I'm going to bore you, so what is the purpose of this study, right? Do you just want to know, explore, just sort of like scan the field and say, what are the issues, right? Do you want to describe something? Do you want to explain something? So you need to actually ask yourself from the very beginning, what is the purpose of my study? Because defining this purpose is going to define your methods as well, right? What kind of data do I want to collect that will best answer my research questions? And then you ask yourself, who or what is to be studied, sampling strategy, and so on. Then you also ask yourself, how am I going to collect my data? Am I going to use interviews? Am I going to use secondary sources of data? Am I going to use surveys? Am I going to use experiments? How are you going to collect data? Now that you have collected your data, how are you going to analyze it? If my study is descriptive, in fact, when I examine thesis or even when I review articles, one of the things that I always look at, whether the author or the student understand the difference between what their research design is and the methods that they're going to use. Because you might find someone saying they're exploring, yet they are using methods that just show that all they're doing here is just explaining something. So there's need to be that link. Or even in qualitative research, you find someone is actually using a theoretical framework that does not allow them to do what they're saying. they are doing. So there has to be that alignment. So you have to think about it. So if I say the focus of my study is exploratory, it means everything that I'm going to put in there, from the methods to the analysis, is going to allow me to explore. Are we together? In some cases, you might have to do all explore, describe, and explain, right? So it's about how you frame your question from the very beginning. What is your focus? And then the research question, the problem to be studied, and the research question is the most important part of your research design, right? A well-articulated research question will actually save a lot of the problems that we often have. Then there are also issues of measurement accuracy. What am I going to measure? Right? You need to know from the beginning, what do I intend to measure? How reliable is this to answer my question? How valid is it? Then you also need to think about, is this study going to be a prospective study or a retrospective study, right? Or is it going to be longitudinal, which means I'm going to have to measure the same phenomenon over maybe a period of time? Or is it just going to be a snapshot, cross-sectional? And if I choose a cross-sectional study, does it truly answer my research question? Or do I need it to be longitudinal? Sometimes someone will come with a research question that's clearly longitudinal, yet the student wants to finish their master's or their PhD in 3 years. And you're asking yourself, how are you going to do that? Because in the first year, you're just doing your proposal, right? How are you going to do the longitudinal study? So you need to think about that. Your research question, is it just going to be cross-sectional? Is it going to be, longitudinal? So a well-designed research study is where all these elements are aligned, ensuring validity, reliable, and actionable findings. So there has to be a thread throughout. Writing, whether it's a research paper, it's a dissertation, is like telling a story, right? And that story, we see it from your assumptions, the purpose, significance of your study in your chapter 1. It moves on to your literature. Your literature must speak to what you have said you're doing, And just by looking at your literature, we should even have an idea of the direction that you're going to go with your research methods. Everything is aligned. And that is why, for us, just as a piece of advice, if you're writing your dissertation, normally when you write, you don't just write your chapter 2 and you forget it. You write your literature review. When you're analyzing your studies, you're opening chapter 2 or chapter 3, or whatever, how many chapters you have of literature review and your analysis, because it has to pick. They have to speak to each other, right? Your analysis and your methodology, they have to speak to each other. Your discussion and your literature, they have to speak to each other, right? So you can't have your literature review, it's there, and then your analysis is there. There has to be that thread. And that thread, you decide it at the beginning, but you refine it throughout the study. There are other elements of research designs that I'm not going to mention here. So I'm going to talk a bit about longitudinal versus cross-sectional research. Longitudinal research involves studying the same participants or same phenomenon over time. And normally in longitudinal research, what you want to do is to observe changes, right? And you also want to identify whether there are causal relationship. Does A cause B, right? And in cross-sectional research, often what you want to do is to examine participants at a single point in time. So it's like a snapshot. What's happening, right? How are students experiencing maybe this particular module in 2024, right? Because we have a new lecturer, so we just want to explore that. That's cross-sectional. So it is less resource intensive. However, it's very difficult to use a cross-sectional study to measure causality. Though it's possible, I've done it myself, but it's very difficult to measure causality, whether something causes, because you only have information at one point in time. It can work, for instance, if your design is retrospective, then maybe you can collect retrospective data together with the data that you're collecting at this particular time. So that way you could use that to also measure causality. Some of the challenges when doing a longitudinal research is that, there's what are called maturation effects. So for instance, if I am studying, say, the effect of an intervention, and I'm measuring students' performance, over a long period of time, there comes a point when a student just matures themselves mentally, right? And we might not even know whether it's the effect of the intervention or is the natural process of the students are just developing and maturing. So that's one of the challenges that we have with longitudinal research. And in addition to that, there's also the regression to the mean, where, sometimes the initial scores may actually move closer to the mean because, people are also, they are generally developing as well. In terms of cross-sectional research, one of the main challenges that is determined to observe whether the differences observed are due to the variables of interest or other confounding factors, because we might not have them because all we have is a snapshot of that particular moment. So a well-designed, I think I've said this before, then comes one of the major challenges that we always experience, which is, can I say how many here call themselves qualitative researchers? Those who call themselves, they say, I am a qualitative researcher. Let's raise our hands. Those who call themselves quantitative researchers. And then the rest, we are mixed methods. All right. So the mixed methods group, I think that is like, the safer group. But often between qualitative and quantitative researchers, there's always this ongoing war, right? Which method is better? It's like as if we can't get to an understanding, right? Qualitative researchers always think because these methods can do this, they are better than quantitative researchers. Quantitative researchers always have these, assumptions as well. One is that one method is superior to another, but we all know that these methods can be complementary, right? There are certain questions that can be answered better using qualitative research. And there are certain questions that can be answered better using quantitative methods. In fact, you find that when you actually move from quantitative to qualitative, you're most likely going to have a robust and, a study with very useful findings, because you have moved from what is happening here to why is it happening, right? Then there is also the belief that qualitative research is unscientific, right? Because with quantitative research, you do a lot of statistical modeling and so on. So statistics is close to science, right? So quantitative research is considered to be more scientific than qualitative research. But the honest truth, for anyone who has done qualitative research, you know that it also requires to follow some rigorous methods. In fact, if you were to take those same designs and give them to a qualitative researcher, they will also struggle the same way a qualitative researcher will struggle with statistical models. Okay, then there is the myth that quantitative research is more objective. The honest truth is there is no research approach which is objective, which is completely, totally objective, right? A lot of what we do in quantitative research is sometimes we have to model biases as well, right? Because there are certain biases. In fact, some of the biases, they even come from me choosing one method over another, right? Already there's bias there. Why did I choose to use a regression model here? Or in fact, my data is captured or collected in a continuous format, right? But when I do my analysis, I probably make it into a categorical variable. Most likely, I'm going to lose some information there, right? By combining people, because for instance, if it's matric points, when I combine students with 30 to 35 points into one category, but we know 30 and 35 points could actually be qualitatively different, but I've combined them. So there are also biases in quantitative research as well. And then there's the myth that quantitative research always requires large samples. but we know that you can also use smaller samples, and sometimes they can yield meaningful results when appropriately analyzed. It always depends on what methods of analysis are you going to use. There are some methods that actually allow you to use a sample as small as 30. So depending on the question that you're trying to answer, you can use quantitative research even with smaller samples. Okay, so when I started as a researcher, like many of us, I used to look for the right answers. But now I've learned that true power lies in asking the right questions. So we don't approach research because we want the answers. We approach research because we've got the right questions. I've got another cartoon here. I like this one very much. You question my methodology. Perhaps you should question your personology, right? So rather than questioning me about whether I've used a qualitative or quantitative design, you should actually be asking yourself whether you're asking the right question. The foundation of any research lies not just in methodology, but in the quality of our research questions. So whenever you're doing your research, always ask yourself, what is the question that I'm asking? And that question is what links everything together. It's the thread that binds everything together. And most problems that we experience in research are not due to poor design rather than poor analysis. So where do research questions come from? I think this is what I started with. They come from, like we said, observation of real world challenges. So you are in that particular context, you notice a problem and you are now curious about how do I solve this problem, or I need to understand this problem. In our space, one of the main problems that we often experience is what? Our students are not doing well, right? They are struggling, right? So it's a problem that needs to be investigated. Why are our students struggling? We now have NSFAS. We have a lot of support for our students. You know, why are our students continuously struggling, right? You could want to look at, for instance, policy changes, right? There's a policy government. I don't know how many of us ever think about that. When you look at your phenomenon, to actually look at, okay, what has been happening in the policy sphere, right? To say, could this be influenced by this particular policy? You know, sometimes we miss out on some of the explanatory power of our models because we're not looking at our research problems from that broader perspective. So you might want to look at, I think someone said, your own intuition. Sometimes something just tells you that there's something here, your own experiences, something is not right. I need to investigate it. When we evaluate programs, theories in literature. So this is where we get some of our research problems from. So science, so Thomas Huxley is well known for being an evolutionist, right? But he has said a lot of, just Google, he has said a lot of gems about research, just the research process. Just going through some of the things that he said, you're like, okay, these things were said so many years ago. How come we're still struggling with them now? We also probably haven't evolved, like the apes did evolve to become human beings. So science is organized. He says science is organized common sense, where a beautiful theory may be killed by a nasty, ugly fact. So, I want to give an example of something that I'm very familiar with. Since the 1990s in South Africa, we have been talking about providing academic support to students. if you look at the discourses around that, they've evolved over the years. From in the early 2000s, we didn't really have much support for the students. We mainly have the extended curriculum programs, the foundation extended curriculum programs. But now we have what I call a cocktail of support. Mentorship, first-year experience, study skills, SI, hot seats, you name it. We have all of this. However, student uptake of our services is still very low. Our throughput rates have remained very low. As of 2022, which is the last statistics that we have, our throughput statistics in South Africa are sitting at 31% on average, which means only 31% of our students are finishing their degree in minimum time. And what's even worse is that, most of them are not even completing because they are dropping out. So what is happening? We need to start asking ourselves questions about some assumptions that we have. So despite the theoretical promise of these interventions, the low uptake indicates a disconnect between the availability of support and student engagement. There's something there that we need to start investigating. We are putting in a lot of funding into supporting students, right? We are putting in a lot of effort into supporting students. But we know our students, they don't even attend lectures, right? Yeah. So we can't keep on doing things the way we have been doing them. We need to actually start asking questions. Were our assumptions correct from the onset? Or is there something that we missed along the line that we need to revisit? Because if we keep on doing the same thing the same way and not yielding any results, then what are we doing? And that's the same thing that we need, the same way we need to approach our research. We need to approach our research from a point of view where I have a theoretical framework. That's good, right? But if my results are refuting this theoretical framework, do I hold on to it? Because it's a theoretical framework that I love so much. It's a theoretical framework that I have known, maybe it has been passed on to me by my supervisor, and I'm so attached to it. We cannot be attached to these things because we need to actually look at our research questions and see whether our theoretical assumptions are actually being explained or being made by the data that we have. So I'll give this an example of, that I got this from DHET. Right? It shows our throughput rates. As you can see, even after 10 years, the 2000 cohort, we still have about 44% of students who did not complete their degrees after 10 years of being registered. That is the reality that we have. If you look, it gets better. The 2013 cohort, after 10 years, 76% had completed, which means about 23% are still either in the system or we have lost them somewhere, right? So with all of this that we are doing, we need to then start asking ourselves, are we doing enough? Is there something else that we need to do? Or maybe we need to ask ourselves, are we asking the right questions? One of the things that I always, because here it's me looking also at my own practice, that I always think about is how, for most of the interventions that we have, we never consulted students. They were based on our assumptions, our theoretical assumptions of what students need, right? Maybe it's time we start going to the students and say, what do you need? And see if what student need actually aligns with our own assumptions. I did mention that we now have a cocktail of support. The question is, are we not overburdening our students by over-supporting them to the point that, the support itself, becomes meaningless, right? And also, besides that, if we keep on having interventions where we are not seeing the results, students might also feel like, why should I even bother attending? It's going to be the same anyway. So we need to be asking ourselves now real questions and say, yes, this is what we do, but how can we improve it? A theory represents the best understanding of the explanations for a phenomenon at a particular point in time, but it is and should be subject to future revision or even rejection. Mhm.
I thought once you've gotten your ethical clearance, you can't change anything.
You can.
Identity.
You can. You can. Yeah. You know, it's like, in fact, here at UKZN, actually, that is actually a much easier process, especially if you're changing just a few aspects. It's a lengthy process, maybe if you are really changing like your entire, you know, research design. But if you're just changing one or two things, it's a fairly, relatively, you know, yes, you still have to do that. Yeah. In fact, you don't have to submit a new ethical clearance. You just need to submit what is it that you're changing. It's only different when you're changing, like I said, the entire, because if you change the research design, then you have changed everything. But if you're just changing an aspect of it, it's actually a relatively, you know, straightforward process. So researchers often rush to interpretations that evolve into ruling theories or dominant theories, which can blind them to contradictory evidence. Because we are so, if right now I do research, I've done presentations where you present something and someone will ask you, you know, but why didn't you include language? Because language is a big problem in South Africa, right? And you can tell that the person is so stuck in that they cannot actually see that there could be alternative factors that influence student success. That's not to say that language is not an issue, but it's not the issue. There are so many other issues that we need to also consider. So we have certain biases in general, and these often also manifest in how we do research. One of the biases that we have is we have what are called confirmatory biases. And with confirmatory biases, you only looking for information that confirms the beliefs that you hold or the beliefs that you have. And often that will also show even in how you do your literature review. You only look for literature which aligns with your research problem. You don't even look at literature which contradicts, you know, your research problem. So we have these confirmation biases, and we are always looking. In fact, maybe if I were to just ask a random question, how do you search for literature when you're doing your study? Like keywords, how do you search for literature? Do you ever search for anything that's contradictory, or you search in line with your topic? Right? And as a result, you find what we only know at the end of the day becomes things that are aligned to our own thinking. So we also need to know, okay, what are the alternative things that are being said? Like when doing your theoretical framework, okay, who has critiqued this theoretical framework? What has been their critique? Is it still valid? Because in fact, I would say if you're writing a theoretical framework, for me, the best way of writing a theoretical framework is to say, this is the theory, right? This is how it has been up. These are its tenets. This is how it has been applied. These are its limitations, right? But these are the reasons why I want to continue using it despite the limitations. So if you can show that despite the limitations, the theory can still adequately explain your problem, then you've got a strong theoretical framework. So you need to know who has refuted it, what were their reasons. Are those reasons valid? Then you have a strong theoretical framework. And then another bias that we have is we have a tendency to rely too heavily on the first piece of information that we obtained and use it as a basis for comparison. You can move from you can't move from, you know, some of the theories that we use, you know, because these theories say this, you know, it's like everything that you do, you always revert to that theorist, because that's the first thing that is stuck in your mind. And we are saying when you're doing research, because if your research is to be applicable to real world situations, there comes a point sometimes when you need to revisit that theory and say, this might not be what's happening. I was talking to someone in the morning. There's a certain theory that we like here in South Africa for those of us who actually deal with students in student-related research. It's Tindo. No, I don't know if you've heard anyone heard of Tindo. Yes, we love Tindo so much here in South Africa, right? We even invited him in 2024. He went to most of our institutions, you know, just explaining his theory. I mean, like there's no South African who doesn't know or love Tindo, right? One of the things that I discovered, not recently, a few years ago, you know, when I submitted a paper elsewhere, was that, you know, one of the comments was that, oh, but Tindo's theory has been revised. Have you read what other scholars have said? I had never come across anyone who had revised Tindo's theory, because when I searched for Tindo, I searched for Tindo in the way that I understood Tindo. You get it? And when I read what these scholars had said, I actually realized how they had improved this theory and how it even became more applicable to South Africa than Tindo's original theory. So you need to always consider this. And remember, even the theories that you are quoting today, most of them, their theories have evolved. Their own understanding of their own theory has evolved, yet you are still stuck with what they said 20, 30 years ago. So you need to consider, you know, your own biases and also the fact that theories, they are not cast in stone, right? You are allowed to change them. So how can we ensure that our theories are continuously tested against evidence? Something that was said 20 years ago, it might have been appropriate, it might have been accurate at that point. Is it still accurate today? Does it still explain this phenomenon today? In fact, you know, we are here not just to regurgitate what other scholars have said. At some point, people have to be quoting you and say, according to so and so, right? You can't be the only one doing according to all the time. Huh? Yeah. And the reason why we are always doing according to is because we are stuck. We think, oh, there's nothing that can be done to Tindo. Yes, you can critique Tindo, you can critique Foucault, you can critique Bourdieu, you can critique any of these scholars because their theories, I mean, like, we agree that society is evolving. Everything is evolving. So if everything is evolving, why can't theories evolve as well? They remain foundational, mind you. I'm not saying we discard them. We are not discarding them. But we take what works, right? And we supplement with our own experiences. Yes.
More often when you do that, you find supervisors saying that these are very bold statements. Where you explain where you found information?
So your data, because remember, you are using your own data. They can't refute. If your data is saying something else, why should you force it to actually align with a theory when it's not? That actually would be a finding on itself, isn't it? That my findings are saying something completely different. And because remember, something could be true at UKZN in 2024, but it might not be true at UKZN in 2028. You get it? Yeah. Something might be true at UJ, it might not be true at UKZN. So why then should we use the same theory across all institutions and across space and time? Right? So what I'm saying is when I'm talking about critiquing theories, it's not something that we do in an arbitrary way. We did it steeped in our data. So I've done my research and these are my findings, right? And are my findings aligning with theory? Because even when you've got a theoretical framework, it doesn't mean that your analysis have to align with the theoretical framework. You might have that theoretical framework and then you find that your findings are not aligning with it. And then you can use that to critique the theory and that becomes your own contribution. Yes, there was a hand there.
So during the literature segment, you do analysis and then in the discussion you state anything. Is that correct?
In a literature review.
You can say what your theoretical framework of state exists. And then you do analysis and then you do discussion.
Yes.
State your new findings.
Yes. So it depends on what you mean by new. Because one of the things that you could do is in your literature review, you might actually identify that there are gaps. There are certain things that have not been covered, right? That in a way is something new as well when you identify the gaps. Or you could actually identify that there are conflicting ideas. So there's an idea that was dominant, but then there's something conflicting, maybe coming from another space. So that could be also something regarded as something new. But then you bring this together now in your discussion.
Yeah, I think that was the sweeping statement.
Yes.
So you can, it's the way you word it.
Yeah.
You can say I, or you know, the one, but you cannot state something before you've done it. So that's why it's a sweeping statement. It's just your wording.
Yeah. So anyone willing to share an example where a theory that was very attractive in their own field was disproven by data?
So I recently did a geomedical study on silicosis, exposure of silicosis.
Mm.
So in most of the mines, South African mines, there is exposure to silicosis, but it's been found recently, or a longitudinal study, that the exposure, the prevalence of silicosis is decreasing. But yet we could still find out that the occupational exposure limit has not been, or the the limit of exposure has not been clearly defined based on various confounding factors. Like, for example, it's not only the exposure of silica that has been studied. There's also diesel particulates, fossil fuel that has been used to run those machines. The particulates that have been exposed has not been studied along with it. So there's confounding factors of compositional, mineralogical factors that are coming in that have not been studied, that have not been recorded properly. And yet you can still see that people there are being data saying that the exposure of silicosis or the prevalence of silicosis has been decreased. But yet it's not, and there's different particulates. There's PM 2.5, 2.4, and micrometers. There's also PM10 that have been there. So PM10 is something that you find in most of the mines, but there are also prevalence of PM 2.5. Very, very, if you have a respirator too, you can't still, it cannot still stop it. Something like that. In advanced studies, or probably in a remote mine, this has not been studied properly. But yet, it's condescendingly said that, prevalence of silicosis has decreased. The mine industry has put away with silicosis, very, compared to the 1990s to the prevalence of it right now. But you can still find that silicosis is still existing.
Yeah. So from what you're saying, it could be an issue where there's been more focus on, what is known, right? And people they are not trying to sort of like push the boundaries of the field to say, what else do we need to know? And I think that's what we need to do. Whatever field you are in, you need to ask yourself, what else do I need to know, right?
Most of the cases, we subscribe to a European standard.
Oh, yeah.
We always subscribe to European standards. So that is always a condescending factor. Also, sometimes confounding. I mean, when you look at the health issues, there are many health issues or health littering issues. There are many things that litter. Smoking habits can also litter the situation of lung syndrome. Normally particulate matter. Smoking, TB can also be a problem. And TB can be caused due to not only silicosis, can be tuberculosis, something else that they've already acquired. So there are a lot of factors that, looking at limited factors and say, this has decreased or something has improved, changed. But yet, and that's a longitudinal study. Most of your health effects are, especially in silicosis, it's a longitudinal study, at least 9 years of study, probably 10 to 21 years of study. If you look at what happened in the 1980s, the population who worked in the mines were migration. They used to come from Lesotho, or they come from the rural areas in South Africa to work in where the money is set up. But now what you see that is, as things have changed and a lot of a lot of policies have been in place. You can see that people who are working easily working more than 5 years, more than 9 years, and these kind of silicosis lab, actually, a progressional disease
Mm,
doesn't happen today or tomorrow
mm,
or within 5 years. It does. You see symptoms, but most of the time it actually prevails after 8 to 9 to 10 years. So the duration of exposure, the exposure limit. Yeah. So it is not, it cannot be a European standard in one place, depending on different neurological.
context
compositions.
is
Yeah.
very important. Yes. I think there was a hand here.
He's funding all the research.
Right.
So that means they don't have to speak to medical workers. So it's funding the research. There are a lot of self-interest and you need to find out who is funding.
And the compensation policies too.
Okay, yes.
I think I can give a little simpler one is UCAZN, Unified Theory of Acceptance and Use of Technology.
Mhm.
UCAZN has moderating effects. When the theory was brought about, that they said males are more, there's a tendency for males to adopt technology more than females.
Mm,
In the old days.
mm,
Our research, I found that was not true.
mm.
These days, females adopt technology just as well.
As much as men. Mhm. Okay.
For me, I studied food security
Mm,
and I did my coursework study like 10 years ago.
mm,
And the 4 dimensions of food security was still the thing from beginning in the 1960s.
mm,
There'd been like this gradual kind of understanding agreements on the four things.
mm,
And now 10 years later, there are all sorts of things that are coming through the sustainable farming systems and because the moment you start talking about sustainable farming systems, you start talking about ecosystems and social ecological issues, and then the social ecological issues are tending to not refute per se, but expose the limitations
Yeah.
of the 4 pillars of food security.
mm,
And that it's been such a huge disappointment of mine because now, I'm like so excited, and over the years I've been like thinking about this and then kind of like, yeah, I'm getting it. So I'm gonna do, like
my
it's gonna be very nice and quick, and then you get there and you
Realize,
start looking at, because there's so many other theories that if I continue thinking about these 4 dimensions, I might, look, people
you'll be stuck in the past.
where you come from, kind of a thing. So it was a bit of a, it's exciting, but it shows how the phenomenon of food security, we got with the 4 dimensions, it was complicated, but it is even more complicated now, and studying it is even more interesting.
Okay. Yes, I think there was a hand here.
Okay, so I'm in forensics.
Mm,
I actually do research on forensic autonomy,
mm,
and there's this theory we've been using, trying to estimate time of death, post-mortem interval. So the popular theory is when we use total body score against ADD is accumulated degree days. So we measure daily temperature readings and then try to analyze it with the body scores, the composition body scores we find in carcasses or maybe bodies, decomposing bodies. So now there is this theory in 2005 by Megesi, I think in Pretoria, UP. So it's a modified Galloway theory of 1989. It's a very popular theory. When you look at so many research articles, you see so many people using ADD, TBS. Now, when I did my study, we tried, first of all, it was kind of the first study in my country, in Nigeria. So we tried to use that same theory, the ADT. Then we could not accurately estimate time of death. So what I did was to now measure all the other factors that could influence the composition. And then that gave us a more accurate theory. So now we added both temperature, humidity, and so many other things. So we now used these other factors and variables and computed using a regression model. So we're able to develop a regression model that could estimate time of death accurate. So the popular theory was just using TDS and just temperature. So the temperature, because there are different regions in the world, we have temperate region, we have the polar region, we have the tropics. So my country falls within the tropics. Now South Africa is in temperate. It's like the special type of temperate region, the Mediterranean temperate region. So its own temperature is quite different. So you see, some of these theories are specific bound to different regions, So
yeah.
that's it.
All right. I don't know. Is there anyone else? Okay. So theories, while they may be appealing, but we must always validate them through observation and experimentation. I think if there's anything that I have to emphasize today is that do not be stuck in a theory or a theoretical framework, right? Always be willing. Of course, these theories, remember, a lot of work has gone into developing them. So I don't mean that we can just wake up and discard them. No, that's not what I'm advocating for. Some of them might even take a lot more studies, data, and so on. But if the theory is not applicable to your particular situation, then you need to actually acknowledge that, right? And the other thing is the theory might not be applicable now, but it might be applicable in a different situation. And sometimes it would actually be a case of your data, the data that you have or that you are using, right? So all of these are things that we need to consider. Yes.
I like to saw the angle of the question. What do you do in a situation where you disagree with the theory or with the concept that is popular? Especially when you have to publish. Then maybe the reviewer doesn't have this ideology. He is or they are this rational reviewers who believes in that concept. And then you are proposing this is what you found, and this is what you what they're reporting. But they want you to follow strictly that theory. And so because you are saying no, they're giving a negative filter, and then they are turning your paper down. Now, I'm saying this because of experience, and he mentioned something like that, especially when it comes from this part. When it comes from this part of the world, we don't believe that you or we can initiate a new finding or a new theory.
Okay, I'm going to say this. If it was me, I'll take my paper and submit to another journal. If you believe, if you believe so much in your study, there's a study that took me, I think, 3 years to publish, because I was so convinced that what I was doing was right, but I was experiencing the same problems with journals. I submitted to 2 journals, and I could tell that they wanted me to go in a direction that I did not intend to, and I knew it was not appropriate for my context. You submit to another journal, because the thing is, we cannot keep on changing our ideas, our findings to suit journals. There will always be a journal that is willing to actually accept your findings. And it also depends on how much work you've done. Because for me, I love that article so much, and I couldn't just change even a single thing on it. So I had to just find another home for it. That made the most sense to me than having to change it. Even at some point, I even tried, but in the context, I felt like, hi, no man, this is not me. I submitted to another journal, it got published. So I would say you do that, you submit to where?
And we have to find another journal, but make sure it's accredited, but you're going to have to find it.
Yeah.
They must be accredited, right?
But this one was a new species we found, and then we succeeded in even the deposit in the gene bank with a section number. Yet they don't want us to publish it because later on they will find out that they actually want to be the first to report it.
Oh, yes. Or they want to, another very awkward situation that I experienced myself. I submitted a paper to one of the quite, prestigious journals, and it was desktop rejected for one reason. The editor felt that I needed to use a certain method of collecting data for that particular topic, and he even had the audacity to attach a paper that he was a co-author.
Yeah.
Yeah.
Yeah, they were.
He was the co-author on that paper, and he was forcing me to use that method. And I'm thinking there was nothing else. It was just the method that he did not agree with. What's wrong with my method? So sometimes you do experience that. And for me, if you experience that, just find another home for your paper, right? It's important, and find another home for your paper. Otherwise, you keep on, there are certain revisions that are acceptable, right? But there are certain revisions that actually change the core of what you are doing, right? And remember, you are building your scholarship, right? So if you change, already it's changing even the trajectory of the scholarship that you're already building. So I would say just find a home. Okay. So now to those of my friends who love statistics, I found this quote to be very interesting and inspiring. So George Box says, statistics is or should be about scientific investigation. Statistics is not maths, right? Yes, it is informed by maths, but it should be about scientific investigation and how to do it better. But many statisticians believe it is a branch of mathematics. Now I agree that the physicist, the chemist, the engineer, and the statistician can never know too much mathematics, but their objectives should be to better physics, better chemistry, better engineering, and in the case of statistics, better scientific investigation. Whether in any given field, this implies more or less mathematics is incidental. So what this basically means, there are some of us who are into statistics who become so dogmatic in how we approach it. We just focus on what the numbers are saying. The whole purpose of us using statistics is for us to understand phenomena. It's not for us to get the right p-values. It's not for us to get the right statistics. It's not for us to that's where biases come in, for us to manipulate data so that we get the results that we want, right? And I know sometimes it's very difficult to publish, when you have like non-significant results. It's very difficult because the field actually expects your results to be very significant. But I think that's where actually our challenging of, dominant ways of doing things come in, because if using this method and my results are not significant, what does that mean for my particular context? You start asking more questions. It should lead to more research rather than it beginning and ending with us just getting the right coefficients, the right effect sizes, and so on. So this, I think, is probably one or two of my last slides. Yes, these are some of the elements of your study design. However, like I said, all of these elements, they are interlinked, number one. And secondly, it's an iterative process. It's not like a linear process because I did my study design when I was doing my proposal, then everything remains like that. Sometimes you need to go back and say, am I still, is my data, is everything still in line with what I said? Do I need to tweak it? Do I need to change it or not? Okay, so now this, I think, is my very last slide. What are some of your experiences with research design? What are some of the challenges that you have experienced with research design? Some of the successes that you've experienced with research in terms of research design? Or maybe you could tell us what research have you designed and you feel you did it well and it yielded, the best research study for you. Anyone wants to talk about their own study?
So I did the research on, I tried to do an evaluation And I first of all did something like a survey. So during the survey, I tried to analyze different methods of embalming decomposing bodies, actually. Sorry, I'm always talking about decomposing
Dead bodies.
Sorry, I do postmortem, pathology. Okay. All right. So so I actually tried to look at that, and because of the nature of my region and the different approaches, different morticians employed, and the challenges we always encounter in some of these funeral homes. So I tried to kind of do a survey. I discovered there were some methods. It was just a survey, a prospective survey of a period of time, kind of a cross-sectional prospective survey. So in the study, I found out about 3 or 4 methods, and then also found out, we discovered some other things. So in these, analyze these methods, and found out that one of the mathematicians kept claiming, actually we saw results in someone in the method. So I know it's quite, there's what we call specialist embalming, so restorative arts. So it's quite different from the usual embalming method. So it's when you try to embalm or re-embalm a decomposing body after autopsies and all that. So we have to employ different methods and try it out, and so it's not like something. It's not the usual method that we already, or traditional methods that we already. It has to involve combining different methods. This one against this one, and so I had to. So from the survey or from the result, and I'll try to redesign a study using pigs, actually. All right. So we try to get some pigs at early stages of decomposition, and then trying to employ some of these methods. So the design was that it was difficult trying to monitor the decomposition patterns and also trying to score the process of recovering the body back to normal, because the body decomposing and then trying to halt the decomposition and then returning it back to normal. So we needed to design kind of a scale to be able to score, okay, is it working? Is it positive? Is it negative? Is this particular embalming fluid or method actually working? Is it positive? So it was a bit. So what we did was to redesign the same Megese method that we had in decomposition. So we did a reverse. I did a reverse design of that, because the design is at the scale monitors the composition progressing. So I had to do the composition now going back. I don't know if I'm making sense. So the initial scale that we have, the whole forensic taphonomy is all over the world. And we monitor the composition progressing, from the first stage to bloating stage, the body bloats, then the active decay stage, the maggots start chopping the body, and then to skeletons and all that. So that's a progress. Now, what we now did was to do a reverse design. So I did a reverse design. I started restoring backwards. And then at the end of the day, we got a good result. So that was what we did. Thank you all.
Okay. Any challenges that maybe some of us might be experiencing, in designing their research studies?
So understanding what data you're entitled to. For instance, we wanted to study at-risk students in our module. What background information is available to students, and what are we allowed to access in terms of study?
Okay, and in fact, that's the next session. I'm going to go through all, in fact, maybe not all, most of the data sets that we have that we can actually use that for. Yeah. So are we going to talk about that? Yeah, and I think if we have time, I'll also do maybe an illustration of how to access like Power Header, which is one of the sources of data that we have. Yeah. Mhm.
So I'm a bit stuck at design because I realized my topic, as I've said, is the field is progressed. And right now the gap is around integrated approaches. So in food security or food security intervention, we find that most of the intervention analysis is about maybe like one aspect and looking at it and then assessing that maybe from market access or, but then how about, but the reality on the ground is that market access is not like something that just happens just on its own. There's always these different things that happen, and most of them are institutional. And so the integration, then I spoke to somebody and said, I need to sort of have like an integration, but then how do I look at a number of interventions against the outcome of food security? And then they said, well, you need to come up with an integration index. And I was like, okay, so I'm a social science person, and I look into what goes into integration index construction. There's a lot of statistical stuff that is that
you can learn that.
I mean, I've been reading, but I mean, it's really challenging. And it's I was happy to hear things about clustering and factor analysis and those things. But I'm just like sitting here, like trying to listen and find out what else one does from either cluster or factor analysis, and what do you do, and also just to find out whether you sort of, I mean, how do you even come up with how do you even like weigh your indicators? Like, is it
you use research. So here's the thing: what you can actually do is there will probably be studies that have been done on that. Definitely there'll always be, René Descartes always says, there's nothing new under the sun. Someone else will have done it somewhere or in a different context. So that's where now you need to do a thorough research now to see what has actually been done on that and see how you can actually come up with your own index. And it also becomes an opportunity for you to learn, because you can actually take even a course or sit down with a statistician, work on it, master it yourself, because it's going to be your own contribution. So I don't think that it would make sense for you to have such a contribution and have it done by someone. You need to create it yourself. So you need to know how to do it. And it's things that you can actually do. You can learn, you can take like some, I don't know which school you are registered in, but you can take some non-degree papers, maybe courses that will actually teach you a bit of statistics, the statistics that you just need. Or like I said, you can take the MOOCs. There are so many out there free, you don't even need to pay, and they're self-paced. But I wouldn't advise coming up with such an index and then you get someone else to do it for you. Because after that, you're gonna go out there and say, I developed this index, but you don't even know how it was developed, right? So invest in yourself. So at least you own it and say, this was my contribution, right? And also it's like statistics is not that difficult, right? A lot of us, I think we just have this fear when we see numbers, we think it's not that difficult. The reason why it's so difficult is because you see the numbers, you see the sort of like complex explanation. first of all, understand, like for instance, talking about factor analysis, understand what is the philosophy behind factor analysis. Once you understand it, when it becomes much easier. Because remember, doing it is something that you can actually do using software, but you need to understand what is the philosophy behind it. Why am I creating this index and why am I doing these particular steps? If you understand that, then it's fine, even if you don't eventually do the actual development of the index on the software yourself, but at least you've got that philosophical understanding of what it is.
The interesting part is this comment all the time. It's like, okay, you are at master's level, just do the basic and then move on, kind of a thing. But I mean, I think it's really good stuff that I'm coming across. But then it's like, okay, you're running for time, and then but you don't have the time to study all this new stuff, but it's really important stuff.
Okay. All right. I'm going to open the floor for any questions before we move on to lunch, and then we'll come back for the second session. Any? Yes.
Yeah, question. Just a recommendation for people doing their masters and going on to PhD. So important to get the proposal right. The research design must be in that proposal. Then those further steps are a walk in the park, as you've got your roadmap. But if you come across those problems, the new things, then is when you can adjust the framework. And you can say this is a new finding that wasn't in the design, but proposing this is a new thing. So always go back to your theoretical framework to the base. Always use it to the foundation, but then when you find something new, then you say, this is what I found, this is why maybe this theory is not hold.
Yeah. Yeah. I don't know. Any other comments, questions before we move on to lunch? Yes.
Thank you, Prof. I was collecting data, and I discovered that the more I approach respondents, the more I get problems. So in one of the it's a comparative analysis of the implementation of disability policies in universities.
Mm-hmm.
Well, yes, a lot has been done, but the strategy of addressing those issues, that's what we need to do. But when I was approaching in one university, the first person that I approached for an interview told me the university is divided into different campuses.
Mm-hmm.
In that campus, he told me that there are no students with disabilities here. And I said, exactly, that's what I'm investigating. Why are they not here? How are you implementing the policies?
Mm-hmm.
So that's one of the problems that I realized, that the issue of policies is still glaring in some universities. Then I went to another university, the Department of Mining Engineering.
Mm-hmm.
And they said, no, you'd rather go to electrical engineering because we do not have students with disabilities, more especially the ones in wheelchairs. And I said, exactly, that's the problem that I'm having.
Mm-hmm.
Why don't we have them here? So I was trying to look at the implementation of those policies. So the more I got into that, the more I got programs that still needs to be investigated as to why those universities do not have students with disabilities.
But is it true that they do not have students with disabilities? Because you just spoke to one person in one, like you're saying, if they've got 5 campuses and you spoke to one person in one department, what if they have students with disabilities on other, campuses? Unless, for instance, if your target was those kinds of disciplines.
Yes, I went to other campuses.
Okay.
And I also could find other students that gave information that were willing to participate. But I was worried about those that are saying we do not have students with disabilities in this department. And it was at the reception point.
Most likely they don't know. Yeah, just speaking from, you know, my experience in the university, most likely because right now, if you were to ask me how many students have disabilities in the College of Law and Management Studies, I might not know. I probably will know the ones that I've interacted with. So I think maybe you might need to change your approach and actually interview people who have access to that information. A receptionist might not even have access to that information. So you probably need to, you know, people who have access to institutional information in the different, like for instance, here, we do have a disability office. So you can actually go to the disability office and get that information. So you need to find out who has that information. Because remember, you need to interview the right people. Even right now here at UKZN, there are so many lecturers who don't even know that they've got a student with disabilities until it's exam time. You get it? When now disability office comes and says, these students, they need, you know, these kinds of conditions and so on. So if you were to ask that lecturer at the beginning of the semester, they'll say there's no student with disability. But by the end of the semester, they now know that they have 5 students with disabilities. So maybe, you know, you need to refine that and make sure that you are interviewing the right people. All right, colleagues, I think, you know, we can break for lunch. When we come back in the next session, we'll look at data sources, the actual data sources, the kinds of research questions that we can actually extract from them, as well as an interactive session. Colleagues online, we are just breaking for about 40 or so minutes. We'll be back at 1 o'clock.
Oh no.
How are you? Right.
And have to.
That's the blanket.
That's the first part. The first part.
I can say that.
Have the same mindset. Hey, Francis. Relax. Bye-bye.
Never had
You probably don't need it. Yeah. No, so here's the thing. You probably don't even need it because theoretical frameworks are. It depends on what you're doing, right? If your particular problem is, I don't know what you're doing in maths. Is it in maths, pure maths, or applied mathematics? So you might not even need a theoretical framework, a conceptual framework. Because you need to for a certain conceptual that you're using. You probably just call it or whatever it is that you're doing. And there's something that's kind of understandable.
just because illness never mentioned.
So what is your study?
Prices of options. So that's based on
what is
the price of
is an option.
So there's a model that
Exactly what you need. There you have the model. That model that you have is what's guiding us. Okay, so you just calling it differently, but you're already in the model. Yeah.
I'm also from IP, so
Institutional planning.
yeah.
Oh,
Spoke about here, but
Oh, okay. So you're gonna help me. I had a meeting with Rishma and Ayanda. Was it yesterday or the day before yesterday? Just to check whether I was, on track with issues of power healer. Because for me, I come from a social statistics background, and I do use a lot of this data, but I have not used power healer. So I've used all the institutional intelligence data, the head and so on, but I have not used power healer. So it was like my first time I was trying to say I can use it. Yes. Oh, I know. I know why.
And I came across some of the things that people could think like, follow your own mind. At the same time, I don't know which extent, because okay, let me tell you, in my story, I know the science approach and it takes science. But now we need now, I'm also someone who guys know now I'm facing my stuff. Yeah. So is it? We do the same. So you're no, I know. Yeah, of course. But it's yeah. All right. We can go. And I don't want to do it. It's just the one thing. Actually, I saw another thing about the whole thing that I wrote. What have you about it? The different views about the kids. So the thing is, about the balance. Look at some points.
Yeah, exactly.
I was not sitting there. I got mine for myself. Oh, I'm gonna eat.
Have you met?
I love you.
Keep the polio. All right. So excited. Unaenda chacha picha
So you hear the stage.
My thought necessary for
institutional data sources. So please forgive me. I'll try and make it short so that I don't bore you for long. But the next session will be interesting because we'll do the practical of how to just the basics of data in preparation for the exploratory data analysis that we will do. So we're thinking that since people already have laptops, so what we're going to do is we're going to curate a small data set that will be sent to you via email today, so that tomorrow when we do the practical, you have the same data set as us, and then you can actually follow. So today we'll take you through how to download data, how to download data onto your laptop, and then how to access it, just the basics so that you get familiar with the interface. And then tomorrow we'll do the actual analysis. So today, for now, okay, where is the slideshow? Okay, let me put this. There's a slide that I need to delete here. Okay. Okay. All right. So I'm going to take you through some of the data sources that we at UKZN, and what are some of the research questions that we can actually explore using some of these data sources. So we do have data which is aggregated. So meaning that you already it's already analyzed, so you extract it as aggregated statistics. So we do have data from CHE, the Center for Higher Education. They have vital statistics, and in the vital statistics, they will have all information on enrollments, head count, staff enrollments, funding, the different programs, graduation by gender, and so on. So they have all sorts of information. In fact, most of the information that we have within the institution, they do have it, but it's already aggregated. And it's still information or data that can still be used for analysis. And I'll try and show you some of the analysis that I've done using that aggregated data. So for CHE vital statistics, you can access it through the CHE portal. So if you just go CHE vital statistics, it's actually in sort of like booklets. So you have to know, for instance, if you need enrollment data, what you need, and then you actually extract the statistics. But this is not raw data, it's already aggregated. So which means whatever analysis you're doing, it's based on the data that is aggregated. In addition to CHE vital statistics, we also have DHET. DHET, they do from 2011, they do have on a yearly basis, they do publish what they call post-secondary statistics. And the statistics from CHE and DHET, they are always a year behind. Because remember, our graduation was in April, and then we're going to have another graduation with another one in September. So this graduation will only be updated next year. So if you go on CHE, you won't get 2023 graduations, you'll get up to 2022 graduations. Okay. Then we have Power Header. Power Header is a higher education portal for statistics, and it's also you can access it through our institutional intelligence office. I would take you through how to access it. And fortunately, we do have someone from institutional planning here who is actually an expert on how to use Power Header, right? But I will just take you through it. And if you've got any questions, you know who to direct them to. Okay. And then in terms of institutional data, our institutional data is at the individual level, which means you can get raw data, student number, and so on and so on. We do have quite a number, but I just listed 3 that I think we will have access to. So the first one is ITS reports, which we all get like at the end of the semester, you know, with our pass rates, our modules, and so on. So there's a lot that you can do even with those ITS reports. And then institutional intelligence, they archive data in different, I would say, sub-data sets, right? Like, for instance, the cohort data, which is what I really like, and I've used it a lot. But they do have a lot of other data sets. They've got enrollment, financial aid, they've got what else, staff head counts, and so on. In fact, all this data that eventually goes to the CHE vital statistics and DHET statistics comes from there, right? What I like about using II data is that you can actually, you can request them, right, to create a data set for you with just the variables that you need, right? In as much as they have like different, like you've got cohort, you've got what if you need, for instance, data on financial aid, which might not be in the cohort data set, you can ask them to actually add that into your data set. So you can customize what you want for yourself. And all the information, as long as it's information about students and it's captured at UKZN, they have it. So you can customize it. And the way to access that data, you need to first of all get your gatekeeper's clearance from the registrar's office. So you apply to the registrar, you tell the registrar what you want to use the data for. With that gatekeeper's clearance, you then send it to II, then they will give you access to the data. Without that, they only give institutional data to people who use it for operational purposes, right? Like people who make decisions on enrollments and so on. So those ones can get it without the gatekeeper's letter. But if you are using it for research, you need to get gatekeeper's letter from the registrar. And what I like about our registrar's office, I think it's one of the most efficient. If you send today your application for gatekeepers, for me, the most it has taken me is 3 days to actually get gatekeepers letter. So they are very efficient in that regard. You just need to be clear in terms of what you want to use the data for and so on. And then we do have a lot of our student support data as well. So depending on the programs that you have in your institution, we have supplemental instruction, we've got data on the first year experience program. And right now we are working towards institutionalizing an AMS or academic monitoring and support dashboard, which I will take you through. And the purpose of this dashboard is to collect all this data on the different support interventions that students attend. So we'll have like a one-stop repository where we have information on a student who has used the writing place, he has worked with an ADO, SI leader, tutor, and so on. So we have all of that information, which helps us assess whether the work that we are doing is of any effect for our students. And then we have learning management systems, which is our Moodle. There's a lot that we can do on Moodle. Believe you me, it's one of the platforms that is underutilized. In fact, if I were to tell you right now, if only I had 8 hands like an octopus, I don't know how many papers I would write because of the data that is available in our institution, but it's underutilized. People don't know about it, don't know how to access it. I have so many research questions that I have in my head, but I can't write about them alone. And I'm hoping that people are going to take up some of these because they are questions, critical questions that we are all asking. But the data is there, we just do not know how to access it. So there's so much that you can do on the learning management system. For instance, you can just check out how students are engaging with your material that you're posting on Moodle, right? And then link it to whether they are actually passing and so on. And the good thing is Moodle does it for you. Moodle itself is already structured in a way that it actually captures it. So it captures what they call cognitive engagement. It captures social, like for instance, how they interact with their peers. It's already the way the platform is developed, is created around the theory of social constructivism, right? So those statistics that you get already, they're actually in a way statistics to prove or disprove the theory. So that's what I like about it. So you can get activity completion reports from Moodle. You can get, reports on students' activity on discussion forums. For instance, you can get activity on which of the resources that you posted that students are actually engaging with. The Moodle that we all have access to might not give us, it will give us a lot, but it might not give us additional information. You can actually request it from ICS because there's some back-end information, for instance, which will tell you, for instance, how long did the student take on a particular activity. So you won't get that in the normal report that we have, but I think in the back end, they do have, because Moodle has got that capability. So you can get that kind of information. And there's a lot that you can do, both then you can tell whether students are engaging maybe with your quizzes, maybe with your slides, your videos, and so on. And then within your classroom as well, there's so much that you can also do. Course evaluations, the QPA reports that we get is one of the most underutilized source of data. Right? You could actually use that. We normally just take them when we put them in our teaching portfolios, right? But there's a lot that you can do. In fact, I was even thinking, if one person could just do maybe a confirmatory factor analysis of that QPA report to say, is it really measuring what it's supposed to measure at UKZN? Because we have an instrument, we assume it measures what it's supposed to measure. But do we really know whether it's really measuring what it's supposed to measure? So just doing that, we've got the data is there, it's archived at QPA, but it's underutilized. No one really requests that information. We only download those reports when we have to put them in our teaching portfolios. You've got your attendance registers, for instance, at tutorials. Which students we know not all the students do not attend, most of the students do not attend. So which students are attending your tutorials, for instance, right? And that could be a great source of information, which you can then link to other sources of information, like how do they perform in a test, and so on, what is their agenda, and so on and so on. And of course, we've got our assessment reports. So all of this is data that if we were to sit down and start writing, we will never exhaust it. There will always be something to write about. And I think we would know more about our students and the work that we are doing. Okay. Yes.
The question on those data sources,
Mm.
most of them are academic data. So if you want to, for instance, look at clinical data, campus clinical data.
Okay, there should be, I need to check in the, what do you call this? I need to check in the documentation whether they do have clinical data, but it's quite, that is sensitive data. So I think accessing it might actually require a higher level of, ethical clearance.
That is the reason why students are underperforming.
Mm.
Of
Mm. Yeah, so that one
linking that to the academic performance
would be great. It's possible it can be done. The only challenge is that the level of ethical clearance that you have to go through is like maybe way above what we would normally go through. But it's possible because that data is there. It's known. It's only that it's not that easily accessible. Okay, so now what are some of the things
Sorry,
that
Prof. The online, we cannot see your presentation.
Oh, okay.
Sorry. Thank
Okay.
you.
All right. Okay, we'll try and fix it. Okay, let's. Okay. Oh, I wasn't sharing. Oh, okay. Okay. Technology. It's, hmm? Can I open the document first and then share? And then, no, it's not sharing. I need to share first. Where's the Zoom? So it's this one. We're sharing this one, right? Yeah. Share. And then we, okay. All right. Sorry for that, colleagues. I forgot.
Sorry, Prof, but we can't hear you now.
Okay. So Power Header allows you to do this thing. It allows you to do a lot of things. It has got data on all HEIs. So you have access, if you want to do comparative analysis of what's happening, maybe say in a similar program at UCT, you actually have the access to that information. So if you're teaching, say in ISTN, you want to see what's happening in ISTN, you can actually access that, and then you can actually benchmark yourself against your sister institutions. So it integrates data from various institutions, various sources within the institution, and it also uses real-time updates. And also it has got dashboards and reports. These are some of the things that you also have on Power Header. You also have information. You can also do the benchmarking, like I said, benchmark against other institutions. You can compare yourself. You can track students, like do a longitudinal analysis of what happened in 2011 up to 2018, 2019. It can also help you evaluate what's happening in a particular program. And it has got data visualization, graphs, charts, and tables. Right. So it has got all of this information, but I think for me, the most interesting part of Power Header is its ability to actually, look at what's happening even at sister institutions. And I think sometimes we do need that. We do need to know what is happening. What you just need to remember is that you're dealing with aggregated data here, right? And it's not like raw data, but there's a lot that you can actually do with it. So what are some of the research questions that you could actually ask or answer using Power Header? You could actually look at, just compare different institutions in terms of enrollment and throughput, or even in terms of research. You could actually just do that kind of comparison. You could do it even at program level if you wanted to, because you've got that information, right? You could also look at maybe things like how has enrollment funding changed over time, right? Because that information is there, so you could also do that. Another data source, that we have is the DHET data. And there's also a lot, it's also aggregated, but there's also a lot that you can actually do with it. I got this data from about 12 reports from DHET on enrollment patterns, 2020 to 2022. And using this data set, I could actually track, okay, what actually happened, which were periods where we had an increase in enrollments, which periods we had a decline, which periods, where maybe we had fluctuations, and then I tried to link that to, what was actually happening in the higher education sphere at that time. We know in 2018, we had the free education, right? And we can see that there's actually an increase in in enrollments during that time. We also know that, 2000, yes, we were just beginning with the whole transformation, widening of access. We also see that increase happening. Around 2004, we had the majors as well. But then after the majors, there was a drop. What actually happened, after the majors? And then we had an increase around 2007, a drop again, an increase 2009 to 2011. So you can actually explore these trends and say what is happening and what could have informed these trends. What could have been happening at the institutional level? What could have been happening at the national level? So there's a lot, but you're still getting this information from aggregated data. And the good thing about this, if you are going to use CHE data, DHET data, you do not need ethical clearance. You can just sit behind your desk, get your statistics, analyze them, write your paper, publish. No one asks you about ethical clearance, right? So you already, it's an easy way of getting publications, but also understanding more about higher education, but also without the hassle of having to go through ethical clearance and so on. So that's what I like about these data sets. Another thing that I also did with this data set from DHET was just taking the different, there's so much that is there, but I just took, like, for instance, do a comparative analysis, what has been happening nationally, look at university funding, financial aid, graduation, staff-student ratio, enrollment, and then look at, what was happening, increase, decrease, and so on. And one of the things, the interesting things is that university funding increased by about 165%. Yet staff-student ratios have not been decreasing, they've actually been increasing. So what is happening? So money is being poured into the universities, but it seems as if, it's not going to paying staff because we have more staff, student-staff ratio. What could be happening? We see the increase in financial aid. Our students, more students are actually getting financial aid from about 3 billion to about 41 billion in 10 years, in 12 years. That's actually quite a lot of increase. But look at the graduation rates. They've remained fairly consistent, even dipping in 2020-22. What is actually happening? You can start asking questions about that. What is actually happening here, given all of these things, the decreases, the increases, and so on? Then I come to institutional data. Like I said, there are quite a number. If you go to II, they can customize the data set for you. So you just need to know what you need. So that's why the issue of research design that we did speak about at the beginning is very important, because when you have got your research, you know exactly which variables you need from the data set. So this is from institutional data. So the cohort data looks like this. It will have the qualification name. It will have the offering type, whether it's offered as a part-time program or as a full-time program, the student number. It will have an indicator of whether the student is a first-time entering student or not. It will have an indicator of whether the student was in an access program or not. It will have an indicator of financial, whether the student was on financial aid. So financial aid, what they normally do in the cohort data, they don't distinguish, right? So it's just financial aid. But you can then, if you want to make that distinction, you can request data on the different types of financial aid. So you can request NSFAS, what's the other financial, Tutuka, and so on. So you can actually request all of those things. And we know these are different, right? These fundings are different, because a student on Tutuka, some are bursaries, some are scholarships, and so on. So you already know if a student is getting a scholarship, it also means what? That the academic performance is what? So the scholarships themselves, or the funding itself, is qualitatively different. So getting that disaggregated data will actually help you have more insights about the impact of funding. But this one that we have in this data set now is more aggregated, just all sources of funding together. And what you get from this data set is across all colleges, across all programs, is that we actually have a lot of students who are actually on financial aid. A lot, and they are increasing over the years. Okay. Then you have residence, whether a student is in residence or not on residence. And it's very important, right? Because if a student is in residence and one that stays at home, there are certain differences that are there. Some, they might cope well being in residence, some they might not cope well. Some, they are going home, they have to miss lectures because the lecture is at 4:30, but then they have to get transport at 3:30, they have to go home. The one in residence, they do not have to miss lectures, so they can attend all the lectures. And then the one who is in residence, they might miss their parents. And so there are a lot of issues, with just staying in residence. And using that and analyzing that can give us insights into how our students are performing. Then you have your graduation indicator, your exclusion indicator, whether the student is currently registered, whether the student registered for the next qualification, how many years have they been registered, what is the duration of their program, the minimum registration years, and so on. And what I like about this is often when we do, let me try and go back to this slide. I don't have it here, unfortunately. See, it was in the other presentation. Often what happens is when we analyze graduation alone, we miss out on a lot of information because we've got students who stop out, right? So these students, they have not dropped out, probably because of financial reason, they just stopped. They are not registered for that year. They might come 2 years later, right? We've got students who drop out. We've got students who are excluded. So when you just focus on graduation and the graduation indicator, you lose out on all of this other information. But when you bring them together now, you analyze everything. You know what is happening. How many? You take a cohort. And out of this cohort, 500 graduated, 300 were excluded, 200 are at risk, or maybe they dropped out, 100 are still registered, 50 maybe stopped out. So you actually know what is happening to all the students in your particular cohort. And one of the things that we found out in one of our papers that we wrote was that we had a lot of students who dropped out, but not because of academic reasons, right? They dropped out because of financial reasons. Some because they switched to other programs, right? So there will be, if the student started in engineering, doing a BSc in chemical engineering, right? They will be considered dropout. So if they maybe say they don't register this year, they drop out, they deregister for this program, and then they register in another program, the student is still within the institution, right? But somehow we might count them as having dropped out without considering whether they have switched. So it's very important that when you are working with this data, you actually exploit in detail, know some of this column definite, also what is actually happening to those students. Duration and registration here is very important as well because it's different. So for instance, registration here takes into account stop out. Those students who register this year, deregister next year and come back. So the student, it might take, if you just look at duration, it might look like the student took 6 years to finish a degree, but maybe they finished in 4 years, the other 2 years they were not registered. So registered here, it takes into account stop out. Duration just looks at how long from the time the student registered at first. Okay, then you have, whether they are registered for a next approved qualification, whether that was still an undergrad qualification or some of them, because they've gone for postgrad qualifications. If they move to another qualification, then you would have the registered years in both qualifications, the one that they started in, the one that they switched to. Then you also have, what else do you have? Like all grad indicator, it means, if they graduated in a different program. So they started in engineering, graduated in maybe commerce. So you will have that graduation indicator because they still graduated even though they did not graduate in their program. So there's a lot that you can do with this kind of data set. And some of the research questions, you can look at demographic profiles of students who drop out. You can do a trend analysis, have graduation and dropout rates changed over the years. You can do correlational or associative analysis. What are the factors contributing to graduation, and so on. Another thing that you can also do is, which I really like doing, is adding to this cohort data on how students are performing in the different modules as well, especially if the modules are foundational or important to a program. For instance, in a BSc science, right, there are certain first year modules that might be very foundational to that particular program. So I might include those, or modules that are probably considered gatekeeper, or whichever way you want to term them in your module. You might consider those modules in your analysis as well. So it gives you a much broader and deeper understanding of what's actually happening with your students, except just saying, oh, 20% of our students are graduating. The question is, which students are graduating? What is the profile of those students? How do they compare? And so on. And also, like I said, I think in the first presentation, you find that this, it's like these things cannot be static. Graduation or factors that influence graduation 10 years ago might be different today. Right? So we also need to take all of that into consideration. That's why things like trend analysis will come in. Another one that I also like to add to this data set is their matric points, right? The school quintile that they come from, because it's also very important. It gives us an indicator or an idea of how these students are well prepared for university education. And using these data sets requires you need to exploit a lot. You need to know how, like any data, you need to know, the definition of the variables. The fact that something just says matric points does not necessarily mean that you probably need to analyze it like that, right? Because I know, for instance, we've got students that have 0 matric points in this data set. It doesn't mean they've got 0 matric points. These are students who come from, who did the independent board exams. So they just put a 0 there as a placeholder, right? So if you choose the 0 there, it will look as if they've got very low matric points. So those are some of the things that you need to explore. And those students will also be missing on school quintile, because their schools were not quintiled, right? So they will have missing data on that as well. So you need to really explore this data, understand it, know it, so that when you do analysis, you won't make some of the mistakes. Another one is, for instance, first time entering. It's very important. If you're going to do a cohort analysis, you need to know which students, which cohort are you following? Because if you just take students who registered in 2014, someone is going to register in 2014 for a BCom degree, but they are coming with 20% credits from UCT, right? So they are different from the student who started at UKZN with no credits. So when you include that, it skews your analysis. So you must really study these data sets. And the good thing is that there's documentation. And if you don't understand, they can even explain to you. Yes.
What is the risk of bias in the cohorts when you don't have a diverse population?
So obviously, one of the challenges that we have with our UKZN data is that it doesn't really capture a lot of background variables. The main ones that we have, the ones that I've personally used, is your race, your gender, your school quintile, your matric points, what even sometimes you can also, the only problem is that there are not many, but you can also consider, maturity, because we do have, for instance, if a student is a first year student, but they wrote their matric in 2007, you already know that that is a mature student, right? But unfortunately, there are not as many unless if you're doing it for a very small cohort. So we have this. Personally, what I have done is I then use data, like for instance, on academic support, right? Which is not, I doesn't have that data. So it means I have to match the data sets sort of to increase sort of like my control variables. And then there's also financial aid, there's residence that you will get there. You can get language if you want. So you can get home language is also there. Yeah. The problem is UKZN NBT is not really, yeah, so some will have it, some will not have it. So NBT, but if you had NBT, NBT would also work there. So those are some of the variables that we use, and I think in as much as it's not exhaustive, but it kind of like captures a lot of dimensions when you look at it. Because if you take your matric points and your school quintile, it sort of like measures the students' preparedness, right? If you take language, of course, language is another issue. You take financial aid, it's also another important one. You know, it shows institutional support, whether the student is in residence, it also shows social support. Then there's your race, your gender. So it might not be the best in terms of that, that's what we have. And I think it does work. And looking at South Africa in general, actually having those is, you know, it's actually a lot, because I've seen so many studies, we really don't include a lot of control variables because it's not captured in our institutional data. Okay, so these are some of like just some examples of what you can do, but there's a lot more that you could actually do with your institutional data. There's another study that I saw, you know, and I was thinking maybe we need to replicate it at UKZN. It follows students, you know, from graduation, from entry to graduation, looking at all the pathways that they take. We know our students, how they drop modules, pick up modules, move to other different, you know, programs and so on. So and then it identifies the different pathways. And it was quite interesting that in that particular study, they identified that a student who comes in, right, there were about 37 pathways. For a student doing just doing a program, there were 37 different pathways, especially in programs where there are electives, you know, where they pick and drop. So there were like 37 pathways that a student would take to get to the same degree, right? And those are some of the things that we might actually need to look into, and it will help us streamline our own programs. Prof. Rawatla from College of Engineering, Agriculture and Science, he also has his auto-scholar model. And the auto-scholar model is even, I think he identified more than the 37 that I'm talking about, pathways that engineering students could actually take to finish a degree. So there's a lot, and we know you can never know this information just by looking at students. So we need to actually explore the data. Then we have our learning management systems, right? Like I said, Moodle is one of the most underutilized platforms, but there's a lot that we can actually learn from Moodle. So some of the questions that you could actually ask, questions related to student engagement with the different features on the learning management system, you know, the relationship between these usage patterns and course completion. One of the studies that I've done on the learning management system is looking at a program and then looking at the different elements, because there were different, different resources, activities that were there on that particular program. So what I did was I then classified those activities in terms of what they were they like just maybe say interaction with their peers, were they interacting more with the lecturer, were they interacting more with the content. And then I did a cluster analysis, right, to see, you know, which were the interaction patterns based on that. So out of the different classes that I have, I came up with 3 clusters, right? And in one cluster, students were mainly interacting with the system and the course. So which means these students would log onto Moodle, right, look at instructions only and use the Zoom link. They would not look at you know, the other material that was on Moodle. And then you had students who would mainly just interact with the content. They would read all the documents that were there. They would access them and so on. And they hardly accessed anything else. Like some of them didn't even go to the instructions. Some would have. And then there were those that were interacted more with the instructor, with the lecturer. So which means, like, for instance, on discussion forums, they would actually respond to your questions and so on. And one of the things that we found in this particular study was that students who interacted more with the lecturer did better than students who interacted just with the content. Which then brings us to the issue, we talk about blended learning, right? Blended learning is important, but this is also showing us, in as much as online learning is important, but that interaction with the lecturer is also critical. So they need to actually include that in our design. Okay, so this was one of the studies that we did on that, but there's a lot that can actually be done. In fact, there's some very fancy, interesting things that can be done on just the learning management system itself. And then we have the last data set that I want to talk about is our academic support data, which I also feel is very much underutilized. we only see it at conferences and it ends there. We don't see papers coming out of like our academic development people. And there's a lot that you can do. So we do have quite a lot. We have, like supplemental instruction. I think it's one program that's very interesting and easy to evaluate because of how it is actually structured. So, with the attendance registers and so on. But one of the things that we are currently working on as an institution, and hopefully this data set will be available to academics in future, we are working on a dashboard. This dashboard, the aim of this dashboard is to integrate data from different AMS support services. So your writing place, your SI, and so on. So we have this data in one repository, right? And that actually helps us because we will now know what is happening to our students. Right now, if you ask us, we don't know which student went to the writing place. Even amongst ADOs, you might have 5 ADOs in a school, and a student can visit all the 5, but we don't know which ones they visited. So this actually will help us know what kind of support are our students receiving, and which of this support is maybe more impactful in terms of student attendance. So we are currently developing this dashboard, which has got a lot of other things, information. So we capture attendance, we capture student profiles, we capture students, what kind of AMS, they are consulting for. We also capture their performance, their academic performance. We also capture, so it has got those main performance, attendance, and then student biographical information. The good thing about this data set is that because we capture it using student numbers, it can be linked to other data sets from II. So where we need, for instance, if our academic support is helping, we can get data, a cohort data from II, link it to this data set, get information on academic support, and then we can measure whether our academic support is really being impactful. So what are some of the questions that you can actually ask or you can answer using this data set? What support services or interventions have the greatest impact on student retention? So we know, like I said, we have a cocktail of support at UKZN, not only UKZN, I think nationally we have a lot of support. Sometimes I feel like we are overburdening our students, but we do not know which one works. That's why we keep on piling. So now if we can evaluate this, then we will know what works and what doesn't work. So we can also evaluate what is the impact of self-selection on student engagement. And what do I mean by self-selection? Basically, it's the idea that there's a certain type of student who will make use of academic support, right? So these students, naturally, it could be because, they are maybe doing well. It could be maybe because they've got that, background experience of getting support, but there's a kind of students who is making use. And if we don't control for self-selection, we might end up saying our services are working or are not working, yet it could be something else. So we need to know the profile of students who are attending our academic support interventions. And that's where now aligning with other data sources comes in, because we can actually control using the other variables. We could also look at uptake of AMS services, and we could also look at, students' perceived need. Do they really need academic support, and how does it correlate with their actual usage of these services? So there's quite a lot that we can actually do. In fact, I would say, if we could explore these data sets, believe you me, we will know more about why we are here and what we are doing here than we do at the moment. So I just have some questions here, but I think because we kind of like running out of time, I'm going to try and get onto Power Header and just show you some of the things that you can do on Power Header. Then we move on to the next session. Okay, I need a mouse. Where's Kumla? Yeah. I don't know, can I access it using here? Yes. You need to. I think, let me try maybe using mine. Okay. You have to log on is she's connected to data, right? Yes. I need, which one is this? Is this Chrome or what? I need Chrome. Oh, it's not here. Okay. What do I do? Oh, okay. Okay, anyone knows how we can share? Yeah.
Select the window. You see the screen? There's window.
Okay.
Yes.
So I want to share.
Looks like you're sharing.
No, it's not share. It's there on the screen. It's not showing on the
Okay,
project.
so what's happening? You've got two projectors. You've got one extended. You can just either move it that side. It will
Which one is
appear.
that?
So if you come here, either. So which where are you? So there it is now.
Oh, okay.
What you wanted?
So I need, no, I want to show this.
Okay, so
I need to share.
right. So you are sharing on Zoom, but this is not the screen.
Yes, when you go to share.
Where's she?
So there it is. Sorry.
Mhm.
Can we go back to your? So what you want is you want to maybe duplicate.
Okay.
No, you can just go back to Zoom.
No, there is the Zoom.
Yes. On the Zoom app, you need to find the specific window. There's just 3 options on top.
Do you see what I'm talking about there?
Go to share. You see. You see.
Which
It's the first one, the Chrome one. I found the first one.
This one.
Yeah.
But
No. It's not clicking the Chrome. Sorry. It's here. So when you say share.
Sorry, it is sharing.
Which one is this?
This one. This one, the first one. Yeah, oh, it's the same one.
It's the same as this one.
do you know what's happening here?
Yes, you need to duplicate the screen. Okay.
The screen, you need to duplicate
Okay,
the screen so you
duplicate.
can look here, and whatever comes up here also comes up here. So
Oh,
it's the
okay.
display option.
Oh. All right. Okay, so this is the institutional planning portal that we are all aware of. So how to access? Oh, Pumla, you don't have power header. Let me use my computer. Okay, let me use this computer doesn't have power header. Sorry, we're just dealing with a technical issue here. Unfortunately, this laptop did not have power header. So if you go to your institutional intelligence portal platform, right, I'm pretty sure it will look differently for different people depending on the level of access that you have. For me, it's here under access our services, but I think for some people it will be on the, like where those other icons are, right? So you go to where it says power header dashboards, and then you will get this. I'm already logged in, so that's why it's showing, but you will have to log in when you get into power header. So it has got all of this information that you can actually explore, but I want us to, I think I'm going to go to power header explore.
like on the interface of the UKZN.
Yes, institutional intelligence. So it depends on, I'm pretty sure you'll be able to access it if you are academic staff. I don't think if you are student, you don't have.
No, exactly.
Yeah, you can log in with staff details, not student details. So, so this is some of, so it has the HEMIS reporting, operational reporting, and so on. I like the cohort statistics, and I like the program analysis. So you can explore program analysis overview, throughput trends, student retention for single base year, and so on. When I was exploring it, I started with the throughput rates for it's taking long. One of the things that I discovered, and I'm not sure, I think it's something that, will probably need to be explored, is that our throughput rates, according to Power Header for last year, 2023, have gone down. We were at 19% in 2022, but, we had gone down. This is what, okay. It had gone down to 16.91%. So if this is a true reflection of what's happening at UKZN, it really means that, there's a lot that we need to do, because instead of our throughputs increasing, it's actually going down. We're sitting at something like 16.91%, right? But we can also explore other, I think let's go to program analysis. So you go to Power Header, it has got all these drop-down menus. You can choose, for instance, the year that you want, 2021. I'm going to choose 2017 would have been in the system for how long? 6 years, right? I'm going to choose 2016, and then the...
Hello?
6 years. 8. Okay, but would they have graduated in 2024? But remember, our statistics are 1 year behind, so I think 6 years should be the best, right? Then we choose what? Let's use entrance category here, and we choose here. So we're going to choose F. F means first time entering students. Let's try and filter and see what actually happens here. So it then gives us an idea of what's happening with our students. Hello?
You are not sharing with us online.
You explained. I still don't have. Okay, so you can actually see what is happening with the students. No, this is not correct, right? This is not correct, right? Anyone? Can you see what the mistake is here? If we have,
This is each platform.
it's on Power Header, institutional intelligence. No, it's Power Header. It's the one behind. So, okay, if you look at this, right, already you should be able to tell we can't have 18% graduates in the first year of study, right? So it means there's probably something wrong with my filtering. So I need to go back and see what else I probably need to consider. So maybe let me look, is it qualification type? Let's try qualification type. And then let's look at 3-year degrees, and then view report. That's more like it, because now we know there's no way a first-time entering student would graduate in the first year of study. So that's more like it. Now, I want you to just take a moment and explore this, right? We had 1,515 first-year students in 3-year degree programs in 2017, according to Power Leader, right? And 12% dropped out by the second year. 4% by the second year, 2% by the third year, 2%, and so on. All these are the students who have dropped out from this particular program. And when we look at our graduates in the 3-year program, we're actually doing well. At least 66% of our students in 3-year programs are graduating, but they are graduating in minimum +1, right? Okay, so let's try and look maybe at, say, the 4-year programs and see if we get a similar.
Is this for one qualification of?
This is all. You can actually filter. It's like you can, if you want to look at different qualifications, you can filter. So what I'm just trying to show is that what you need to do when you get to Power Leader is play around with it, right? Because you know the research questions that you have and you need to play around with it, right? So if I was to filter, if I had a specific research question, I'll then filter according to what I need from Power Leader. But so this is all. So I think 4-year qualification, why is it that we have 80% graduating in first year? IP people, can you help us understand this? Some data error, or maybe the filtering, maybe there's something that I shouldn't have filtered here. It could be a problem with the filter. So maybe let me try faculty academic only and remove entry cut. Okay, now this won't work. It's not allowing me to filter.
You could actually look at gender.
Gender?
Yeah.
Okay, let's look at gender. But we still want to capture the code. So gender, we look at all. Okay. And then we filter because we need it at program level, right? So I think we need entrance category again, and then we take first time entering students.
I think it will also be better if you in gender, maybe you specify if you male.
Yeah, specify the gender.
Or you want just maybe, okay, I had said all, female, okay.
But if we select all, won't we be able to see the proportions of females and men?
Yeah, that was the
actual. It will just give us the number of females who graduated.
Yeah.
So if we say all, it will give us the number of males and females.
Qualification type?
And kind of
qualification type. So let's do qualification type. And then qualification type, we do, I don't know why the 4-year, is giving us.
perfect. Now we have only female there.
Yeah, but still, what's problematic is that we've got 82% that graduated in the first year, and it shouldn't be like that. However, when we filter this by 3-year programs, it seems more accurate. You see?
Yeah.
Okay.
Because
let's try something else.
If, when it comes to qualification type, is there not another filter, maybe
Description.
category or description? Then you could say like bachelor, 3 years.
Oh yeah, you're right.
Professional, which is
You're
called,
right.
like,
So you're right. So let's do bachelor's. You're right. And then let's see.
Yeah. Think to give us.
No, it's not giving us anything. I think we need to remove that female, the gender, and maybe just put
Make
all
it all.
instead of making it full of females only.
And then check the number of tracking years. Am I still seeing? Is that 6 or 0?
Okay. Oh, okay. I think I know why. I think it's because of the 6. Yes, the tracking years. Okay.
Try 3 years.
Let's try 3 years.
Yeah, 3. 3, 4.
Okay, so that's what we get.
Graduate for.
Oh yeah, so actually this makes more sense. 5,400 first year entering students makes actually more sense for the 4 colleges. So you can just play around with Power Header, right? It's accessible to everyone with the staff number. There's a lot that you can do with it. I just wanted to show you cohort, but remember there is a lot on Power Header that you could look into. Student graduation, multiple basis. You could look at the HEMIS data. You could look at, operational reporting. So there's a lot that you can actually access on Power Header. And it's one of the platforms that really is underutilized. I think I'm going to end here for today. And I really hope that maybe, you got something out of this. And then, when we go back to our respective places, we'll be able to explore some of these, research questions that are still unanswered about UKZN, yet the data is available. So I'm going to end here and maybe entertain just 1 or 2 questions before we move on to the next session. Yes.
I don't think it's accessible to everyone because I tried logging into it and now I'm thinking maybe there's some restrictions.
Really, I think there are restrictions. Okay.
Yeah, some people not.
Okay, but if they request access, they can be granted, right?
Depends on your.
So maybe for those who might not have access, maybe you might, if you want to use Power Header data, you might need to get gatekeepers letter from the registrar first. Yeah. All right, I'm going to entertain maybe just a couple of questions before we move on to the next session. Yes.
Dr. The thing is that is rich graphs, being able to extract, looking at that data and look at the problem. It's strong. But for instance, our tracking and monitoring of at-risk students would be so much better if we had access to Power Header and real-time data so that we could put our fingers on the problem during the semester, not at the end of the semester.
Oh, yes.
See our results. Does Power Header give us that option?
No, it doesn't, because remember, Power Header, UKZN has to feed in the Power Header.
Our data getting fed into Power Header every day.
This is data that is so for that side you won't get it.
Load on. SMS. Usually we only upload things on SMS at the end of the semester. DP refusals, then we upload. But ideally, I know of academics who actually have that kind of like early warning system. So what they do is first test, they send the marks to, like whether it's ADOS or whoever, then they follow up on the students. So at least first test is before the student has actually failed.
What would be great is for UKZN to have its own semantic model.
Oh, yes.
That can be applied to the module. That's amazing. I think the policy theoretically from our students, historical data, this is shown. These are the problems that students haven't got to it. That would be a nice problem.
Yeah. Oh, yeah, thank you, colleagues.
Oh, sorry, someone lost a white drive, right? Power bank. In the other room. If you find it, please bring it forward. Yeah, but something and I any patient, right? Yeah, just more. You thought you were done.
Yeah. Oh, we can start right away. Okay. Good afternoon, colleagues. We're going to try to be very brief so that, yeah, I know that 4 sessions can be too much, especially when we're discussing the issues such as the one we're looking at. So before we go to what we want to talk about or what we're going to be sharing, I want to introduce this material here. It's not presenting, right? This is a book I read, I think some time ago, maybe 2016 or 2015. It's called Statistics 12 using Stata. Obviously, now Stata is Stata 18. But the material in there is still relevant. Probably the structure of our discussions, particularly our demonstrations, might be following some similar, maybe things like data management, visualization with graphs, looking at data, how to import and work with it, summary statistics, analysis of variance, maybe up to linear regression. Then we jump to go to principal components and factor analysis when you're doing data dimension reduction. Some of the other more models, such as advanced regression stuff, maybe in the next coming workshops, we can be looking at modeling approaches. So I encourage you to find this book. I saw a copy at the library, but that was at Howard College. But yeah, you can also, okay, maybe I'm not supposed to say that. You can also buy online. Yeah, you can also buy online, but also there are places where you can you can find it, or I can send you my copy. You can just, yes, yes, I can send you the one I bought. I think among many books on Stata, I've read quite a number because I wanted to really know what's happening with analysis of data. Some are a little bit complex in terms of the approach that they use, but this one is very simple. Probably even, if you're too ambitious, I remember sometimes when I've worked on other projects and I'm also sure what to do, I would read countless number of pages of books just trying to understand how to get this method right. Sometimes you read and the method looks so simple and like maybe it's a little bit wrong. Let me look for another book, You look for another book, you read again until you are sure, like, I think now it's okay. I can begin to. Yeah, so there are times I've read quite multiple books, but this one, yeah, is still one of the books I always go to whenever I need help. And most of you also are most of you are postgraduate students. And at some point, you're going to be doing econometric modeling or various modeling approaches. There's a website called the Econometrics Academy. Econometrics Academy. If you just go on Google, let me see if I can do that quickly. How do I stop sharing here? Okay, so that I can open the window. Okay, where's my Firefox? Oh, yeah. Oh, what's this? Okay, so if you type Econometrics Academy, I think it's very old lectures. They are on YouTube, but there's also this website. So if you're someone who, yeah, it's one of the materials that I've used also over time to actually learn about various modeling. So they've master's econometric models and they've also PhD econometrics. But I think their assumption is that you have some level of understanding. So you need to go back to the book at some point. Yeah, so these are some of the materials that I've used that I found to be quite useful. And I want to encourage you to also be able to access and use these materials. Right. Let us try to go to installing Stata. How many have Stata on their computers? Okay, I see quite a few. On the rest, if you are a UKZN student, or you can go to software rep there. Right. So it's software rep.ukzn.ac.za. So you can go there quickly and then you hit enter. Obviously, it's going to ask you to log in with your details. You go to academic software. You will see that there's quite a number of software. Some of them we're going to use them at least later on in future workshops. So like Amos, we're going to also use NVivo at some point when we do qualitative data analysis. We are going to do a workshop where we also do qualitative data, actually trying to look at big data. You see, these days, most of the data is not only quantitative. Increasingly, we have a lot of useful qualitative data. People post information on videos like TikTok. I remember on my master's dissertation, I was looking for data to want to understand digital transformation so that I can develop the key concepts I wanted, but I couldn't find anything because, you know, digital transformation was still just something that is being said out there. So I went on YouTube and then I collected all forum discussions from 2015. I think from 2015, 2016 at Davos by World Economic Forum. And then I transcribed them and then I used NVivo to model the data. And then there were some interesting trends that were coming from the things people were saying. And I developed the concepts I needed and then looked for quantitative data. That's how I wrote my master's dissertation. And I still use that data. Recently, there is a paper that I'll be presenting at a conference. It's a qualitative study where we're trying to look at how social contracts can be adjusted in light of digital transformation. It's also based on qualitative data I extracted that way. So most of this software, we're going to use them. So in your spare time, if you can install some of them, it will be good. So you go to Stata here, and if Stata 2024, if you have if your computer obviously is Mac, you have Stata for Mac. If you have Windows, that's Windows 64-bit here. Then we have both the software and the license. So you're going to download both. Then you, I've already installed Stata on my computer. So, and I've also downloaded it as well. So you can take, it takes a little bit to download, but yeah, it will be done and you'll be having the software. Earlier on, I'd also said that another alternative is R. We are not using it, obviously, in the current workshop, but you can also download it if you go to the CRAN website here. It's called the CRAN repository, cran.rproject.org. R is free, and it's a very competitive alternative to with a larger community that supports it in terms of developing modules, as well as if you have questions, and it has a larger community than Stata, but obviously Stata is an enterprise software and it's used a lot. It has more credibility. ARA is still, some packages are most packages are user written and it's open source. And for most people, that raises a little bit of questions in terms of, you know, how can I trust many of these modules, but they are always being tested and refined. So it's also becoming a competitive software, particularly for, you know, handling large data sets and for more comprehensive statistical modeling. It's actually called an environment for statistical analysis. Then you can also download, normally with ARA, we normally don't use ARA as a software itself. We try to use it within an interface, or in this case, we use the RStudio software. So when you have installed it, it should look something like this. This is the RStudio interface. I like a black theme. There's quite a number of themes that you can use, some like lighter themes. So it will come with these 4 windows where you can type your code here, and the output window, obviously, on everything you could be doing, then where your variables could be, and then the packages and your plots and so forth. But we will deal with ARA in a subsequent workshop. I think it's a very good language to understand because of some advantages, such as, you know, being free when you don't have access to maybe softwares that we have access to now at UKZN. Right, so that's how we download the softwares. Installation is exactly the same. Don't worry about reading the terms and conditions, you know. You can always just check everything like we normally do. And then, yeah, but please do read the terms and conditions. They are important. They also, you know, kind of give you information on how to update and future releases and so forth. Right, so remember these 3 things: the book, how to download the softwares, and then, yeah, and then also ARA. So today, we are going to deal with the Stata software. We're going to introduce it. So once you have installed your Stata software and you have opened it, you have a window that looks something like this. So you notice mine, this is the one that I'm using. It's kind of, you know, states the various details of the Stata, the company itself. You know, sometimes in your dissertation, you want to tell you want to reference the software. So it kind of gives you details, you know, Lakewood Drive, College Station, Texas. That's where the company is. And the details for the license that I'm using, this UKZN license, is expiring in July 2025. The serial number, my name, as well as the University of KwaZulu-Natal, which is the institution, right? So when you open Stata, you are going to see about 4 windows. There's this little window to your left that is written command, this side here. So everything you are doing in Stata is always going to be displayed. All your commands, they are going to be. So if I type, for example, clear, you will notice that it actually records clear as well as printing clear in the main window. So everything you do is going to be, all your instructions are going to be displayed in that window. Then we have the command window where we can write things like the one that we just saw me now, where I typed clear. We call that the command window. For instance, I type log close, you'll see all the instructions are coming there. It's the command window. That's where we write all the commands that pertains to the Stata language itself. Then to your right, you have variables. So if we load a data set, you're going to see that the variables are going to show here. We'll do that shortly. And then below is the properties that pertains to the variables here. So the one in the central, the bigger window, that is where all your output as you are working, whether you run a table, you run a regression model, whether you are looking at the information regarding your data, everything is going to be presented. But there are also other windows will be opening from time to time, particularly when you're doing visualizations, when we want to browse the data, that is to get a visual inspection of what the data structure actually looks like. You'll also see that you have your normal tabs. Some names are quite familiar when you have been using like your basic Windows software, like your Excel. You'll notice you have file, edit, you have data, graphics, statistics, user, window, and help. And the people who were developing Stata wanted a program, I think, that aligns with common sense thinking. So even though there is, you'll see that we're typing commands, there is also a point and click system that also reproduces the same basic commands so that we can be able to learn the software or the language system that it uses as you are actually doing it. Normally we like coding or actually writing down the instructions because we don't directly type commands in Stata like this. The disadvantage of this is once you close Stata, or maybe there's a problem, whatever you're doing is lost. Or sometimes maybe you are working on a very large project and you want to document all the steps you're doing so that you can shut down the computer and still come back and continue running at a later date. So we use what are called do files, which is what we're going to demonstrate shortly. So when you click on these tabs like file, you have basic information that is there. I'm not going to go into details with it, things like open data, subset, view, and so forth. You go to edit, you can adjust the preferences, they're basic commands. The ones that you are mostly going to be using when you're working with your data is the three: data, graphics, and statistics. So in terms of data, these are the commands you use. Mostly we're going to be typing, but it's also things that you can do with the point and click system. So if you want to describe your data and you click on data, it gives you various options. You know, describe data in memory, describe data contents, code book, and so forth. If you want to edit your data, whether you want to do a data edit or you want to do a data browse and so forth. So it gives you all these options. Graphics is where we have the various kind of visualizations. You can see the list there: two-way for scatter plots, bar charts, dot charts, pie charts, histograms, and even some other complicated plots, like when you run your regression and you want to sort of do post estimation and view the data in the background. It also allows you to do quite a number of these things. Then there is almost every statistical model, maybe except for some machine learning models that are there in Stata. There's almost the list of every model you are likely going to use. So Stata is comprehensive enough to actually provide the interface for implementing any model, from your linear regression, your nonlinear models like your logistic regression, to panel data models. They are also there if you go to longitudinal or panel data. You'll notice that even under panel data models, there's quite a whole lot of other models. Item response, structural equation modeling, all these other models. Stata provides sort of even doing your descriptive analytics. Stata has the interface as well as the tools that can be used to run the analysis. Right, so when you look at these icons here, we kind of use them to interact with the software. So the one here that says open the yellowish looking envelope or the yellowish looking thing is when you want to open a Stata data set that you have stored somewhere, you click on it, it goes straight to look at your file. So I was working on this. So you could see there is some of the projects I was doing on principal components analysis, on partial least squares, structural equation modeling, etc. So if I want to use any of this data, I can just click on the data and then it's opened in Stata. Save simply means save, but normally we don't click save. Normally when you click save, all the changes you might have made to your data are automatically saved in Stata, which is what you don't need. Sometimes you want to keep your data raw and then temporarily make changes and then always have the data remain raw in case you want to change your model, or you might have to find yourself retranslating your data or downloading and cleaning your data again if you make the changes permanent. Then print, that is if you want to print any section of your results and so forth. If you want the code book, if you want to open a log to sort of document everything that you're doing, every result that you're using. Oh. Say you want to create a logbook that tells you everything that you have done and you want to print it out. You can open, if you click log here, Stata would ask you where do you want to save the log file, and you can enter your details, give it a name. So the log file, you can print it either as a Word document. So sometimes when somebody says they want evidence, of how you analyze your data and stuff like that, you can actually attach your log files because it's the list of your commands and every output that was produced while you were doing the analysis. Then you have this what do you call it? It looks like a bar chart or a histogram, something. Like whenever you are doing plots and you want to bring them back within the software, you click that. Normally Stata, when you run a chart, you'll see when we demonstrate, the chart is produced in a separate window. But if you want it to be within the main window so that it can also come out in your logbook, you click on that and it returns it back. Then this is probably something that we're going to be using a lot, the do file link that says do. So when you click on it, you get another little window that looks very much like this one. So with this little window, we are going to use it to store everything that we need, that we can be doing, particularly the commands. So we store and save the commands we are writing on the data and not the changes we make to the data. So whatever output we get is stored in the log file. Whatever commands we are typing, we store them in the do file. And when we close data, we don't save on the data so that the data still remains raw, but we have all the output. And also having a record of your commands and whatever you are doing in a separate script, it means that if you want to refine the way you are analyzing your data, maybe now you have more information or you would want to continue with the analysis and do research somehow, you can still come back and make changes on the do file and implement them on the data, which is quite a more sort of, what can you say? It's less prone to error when you do that. You can even take your do file to someone who is more experienced. There's when you register Stata, for example, there is the Stata forums where there's a group of researchers. Many people you are going to meet are also people who have developed many of the modules you'll be using in Stata, who are always active and they are willing to respond to any question that has been presented there. I normally use the Stata forum and sometimes I also contribute. Yeah, which is something that shocked me the first day I did it because it was very hard to learn Stata, to learn the language. So the very day I was writing a command to help someone who was requesting, I was like, am I actually doing this? It was like that moment where I was like, okay, I think it paid off after all this time. So I encourage you to also register on the forums. They are really useful. They help with, so you can use your do file to communicate what you're trying to do. If you cannot, understand, I want to try to compute this, but the thinking behind it, there are people who are willing and always active to contribute there. So Stata uses basic rules of grammar, just like how every language that we use has its own, what should we call it, syntax? You know, the way the language is used. So Stata also has some basic rules. I'm sure as you'll be using that book that I'm going to send, that I bought, you, yeah, you don't normally think about these things when you're accessing content online. So yeah, as you'll be using that book, you're going to see that there is a lot of information in it. And I think especially if you are able to, if I manage to send it today, and you are able to just look at the first section of that book, I think it's a few pages, maybe 20 also. Come on, you guys are academics. You read journals, you know, unless you read the introduction and then you read the conclusion. So it's about 25 pages or so. So if you look at it in just one night, by the time we come tomorrow, you'll basically be understanding exactly, you know, and yeah, that's what a workshop is all about, you know, to make you do things that you definitely cannot do under normal circumstances. Right. So what I want us to do now, if you have Stata open, probably just going to be following some of the things I'll be typing here. Let me just try to zoom. So, how do I zoom here? So that at least this is okay, view, sorry. Right. Okay, so there are some just basic commands I normally write whenever I'm running Stata. Just like clear, I'm basically telling Stata, I wanted to clear everything that is in the what system so that I'm working on a clean slate. Then I always say capture log clause. Obviously, by the time you are proficient in it, you won't be writing in full. Like capture, probably just be saying cap, so stuff like that. Then I always say set more off so that Stata can always show me all the output at once without me having to press space all the time. Then I always create a directory or direct all my output to a specific directory. In this case, I'm going to use the teaching and learning. I'm going to be using the teaching and learning folder that I created. So users, and I'm going to refer to my computer, is located in downloads. Here, and then as teaching and learning unit. Let's hope I did not make an error. If I didn't, then it should take me there, right? So it's directed to the teaching and learning unit. Then I'm going to create a log file. So I'm going to say log using and just give it a name. Let me just call it data analytics workshop. Then I'm going to tell Stata, please save it as a text and also replace if there's a file that is like that in there. So it creates a logbook with a date and the location. So it's called Data Analytics Workshop. It's a log file. It's text so that I can print it as a Word document and the exact date when I opened it. Right. So if you go to File and on Stata and you go to Example Datasets, as if you're going down after print, you see that command that says Example Datasets. Stata has some datasets that it sort of houses that we can use to just, you know, get a feel of what the program actually does. So I'm going to click on example datasets. So there's a list of these example datasets that are there. Yeah, there's the voter dataset, the autos dataset, and so forth. They are designed based on whatever you'll be learning. You know, when you're running Stata. Normally, in most textbooks or what are called user reference manuals, which is a very important aspect of Stata and R. Like when you go to Stata and you have anything that you're doing from descriptive analysis to regression modeling, you can simply look for a reference manual that actually gives you a complete list or a complete guide to how you actually perform a particular modeling approach. Yeah, it's a good reference as long as you are willing to read it, right? but if you're not willing to read it, it's not going to be as useful. But yeah, SETA has these reference manuals. Also is what are called, they call them, I'm forgetting, they are like reference manuals, but they have a very special name that they use. But it's like documentation on every project, on every module that is written. So if you are not so sure how to utilize that particular sort of module or the particular methods in it, you can always go to refer to the documentation or the manual, and you are able to know exactly how to implement it in that particular method in your research and so forth. There's also another important thing that probably we'll look also into detail tomorrow when we're doing exploratory data analysis, is the issue of metadata. Whenever you're working with any data set, the very first thing you need to do before probably even importing the data, or you can import the data, but before running commands and trying to look at the structure of the data, is to read the documentation behind the data, how the data was collected. When you look at a data set that I've used that have really good documentation, when you look at the National Income Dynamic Study, or you look at the quarterly labor force survey, when you go to Data First, it's freely downloadable. They give it out as public data under the Creative Commons license, although UCT always want you to tell them exactly what you want to use the data for before so you create an account and you can access the data there. So they have documentation that tells you even each and every variable, how the variable was measured. They also tell you the context within which the data was being gathered, was being collected, the interval. They also give you information on how they imputed missing observations in some of the other data. So this information guides you as you are manipulating, transforming, and working with the data to prepare it and to sort of remodel it for your specific analysis. So it's very important to read the metadata before you start any analysis. Unfortunately, one of the challenges with some of our institutional data is it doesn't have any metadata at all, right? So it's whatever you can make of it. It's also one project that we have been doing with Professor, where we're actually taking data in the teaching and learning unit and writing technical reports on it, so that when people who are going to use the data in the future or who are going to be collecting data, they have at least a template that they can begin to use in how data can be stored and it can be used also in the future. So metadata is very, very important, particularly when you are using secondary data sources, or even when you're collecting your own data, whether it's a survey or something. Try to write some sort of metadata as you are doing maybe when you're designing the survey question, you can begin to write the metadata, explain your variables. Yes. So data we are talking about are the values that are connected with the various features you're going to be measuring. So for example, if you have, let's say, a variable in your data that says gender, and your values in gender are going to be what? Male and female, or any other sort of category that you can put on it. So the values that when you say the gender variable has maybe 3, 4, 5 categories, those are the values associated with it, right? The metadata now is the information behind behind the variables. So where you tell us exactly how the gender variable was created and measured in the study, and probably why you were measuring gender in this particular study. So it's information that gives us the context of the particular variables we are observing in a data set. And also it tells you the measurement scales. That information is useful when you are then trying to analyze and make use of the data. So we really encourage people to read the metadata before doing any analysis. Mostly you hear people say, no, there's a data that is available, it's the needs data. I'm just going to use it for my analysis. And then they go to the needs data later on and find that, okay, it doesn't seem to be fitting what they want to do. And then they have to start trying to find other ways of, it's hard to try to use a data set that doesn't fit your context and make meaningful conclusions. It's really, really hard.
Because, for instance, I'll give you a very good example, right? When you talk about graduation throughput, we seem to be talking about the very same, right? And you find that DHET defines it in a specific, right? And the way that DHET defines it might even be different from the way UKZN defines it. So if you do not have that metadata, right, you might think you're dealing with the very same variable or very same thing, but it's actually different because of how it has been defined. It's always important to know, okay, so it's basically like saying what was in the minds of the researchers when they were collecting this data.
Yes. Yeah, thank you so much, Professor. Yeah, I don't know. I want to open a data set. My presentation of the set software could have been a little bit crude. Are there any questions or things that you may say, okay, how does this actually work? Yes.
Mine doesn't allow me to, so I tap the to-do file, but it doesn't appear.
You have to run it.
You have to run it. Oh, I did. My apologies. I didn't show that. I was just doing. Okay, so every time you type a command, you select it first. So you can select it instead of every command you want to run line by line, you select it. If you don't select it, it will run the entire do file. And sometimes you don't want that because you are sort of iterating as you are working to say, I want to run one command at a time. So you have to select it as you're observing here. So you can click either Control Do, or you go to this little icon here and you click it and it will run the command. Yeah, it's called execute do, but sometimes I just like selecting and then clicking Control D and then it executes. So when you execute from a do file, you notice that it doesn't write the command as clear as what you're saying. You're seeing maybe when I was first writing the commands here. Now it references the do file. It says do. So you know that all these commands are commands that are coming from my do file. And also, remember, once you create a do file, save it. So you can always click save and go to the place where you want to save your do file and then give it a name so that when you want to access it again, you are able to access the particular do file. So yeah, I don't know. Are there any questions also on just the platform? So I think we're all okay. Okay, let's try to just do one. Oh yes. A do file is like a script or what should I say, jotter. Yeah, it's like a notebook where you're writing all the commands that you are running. Just that, yes. Yeah.
Kind of like the process of all your activities. So I think, like you say, it helps in the sense that you're not manipulating the data, right? You're not doing any changes to the data. All the changes are in your do file. So if you make a mistake, your data remains as it was. You just correct the do file. And the advantage is that, you can always run it at any time. So even 10 years from now, as long as it's got the same data in the same format, you can still run it and get the same output. So it's like your repository. Just think of it as your notebook where you are keeping all your analysis.
Yes.
Template do files where you could just download a template and start it when existing data set.
Or Starter has some practice data sets as well. And as they do have,
if you wanted to do a specific modeling technique, you weren't really an expert. So no template for that method.
Is the econometrics.
Yes, the econometrics website, there are do files on every method that they've run there. Actually, there's another news source also where you can get you can create your own do files. It's called ChatGPT. No, seriously. But sometimes the problem with ChatGPT is it can be terribly wrong. I remember this other time I was trying to run iterations of a specific code. I was doing a panel data model and I'm not getting it. It's not running. And it's the most frustrating thing ever. You know, I remember the first time, sorry to sort of digress. I remember the first time using Stata. The one thing we were taught back at school was to get everything right. You know, there was no space for failure. And it kind of molded us that failure was such a big thing, but I was failing. That was the problem, you know? So being taught Stata the first time, I tried to run the commands and then there was just red, which just tells you that, you know, what you're doing is wrong. So I lift my hand to the lecturer and then he comes and I say to him, is there a way of removing, you know, the red? And it's like, I think that you're worried about something else. It stays there. It means you did something wrong, deal with it, you know? So he told me that it's okay to fail. Continue doing it. So ChatGPT sometimes gives you commands that don't even exist in Stata. I think it just thinks that this can be possible, and then it kind of gives you. But it's a good place to start. You can really be doing prompts like when you're learning, how do you find this information? And it can also show you exactly how you do it. It can be a good place to help when you are learning and you want to be a little bit more ambitious. You know, in software, for data analysis, as in mathematics, they say practice makes what? Perfect. So the more you do it, the more you try with your data, with different data sets, the more you easily master, particularly the language and the entire modeling process associated with it. Yeah. So I'm sure, yes. Oh, okay. In terms of the data. Okay. Right. So what we did at first was, okay, we installed Stata and then we opened Stata. Then after we opened Stata, we're just talking about the various windows. I think that is still probably clear. Okay, fine. Then after the windows, we opened a do file by going to this. You see this little thing that looks like a notebook with a little pencil on it. So if you click that, that is what we call the do file. You click that, it opens the do file. Then as soon as it opens the do file, then I was talking about how there are specific commands I always just type. Because I'm always working on Stata. Sometimes there could be data still in memory. And when you, yeah. Or the data, the example data sets. Okay. So on the example data sets, you can go to file. You see on Stata where it says file. And then you click, you see where it says example data sets. Yeah, you click on that, it opens that window. Then under description, it says example data sets. So you click and then it lists all these data sets, right? So let's look at the auto.dta data and you can just click where it says use there. Then it opens that data in memory. So you notice here it is recorded system use auto.dta. So Stata data sets are recorded as DTA. If I wanted to import any data from Excel, I can go to file and then I say import here. And then I can search for the kind of the format of my data set. So you see Stata can incorporate other data. You can incorporate an Excel spreadsheet, CSV files. You can also import data from SPSS. SAS, you can import data from almost all the major platforms. You can also import data once you are in Stata. So I think we'll demonstrate particularly importing data from Excel tomorrow when you're doing exploratory data analysis. So we are going to type a number of commands just to get to get a feel of some of the aspects of what Stata can do. So now we have data. If we want to understand maybe each and every variable in the data, or to just have a feel of what the data structure looks like, we can first start by typing describe. So describe does exactly that. You know, it describes what? The data. So I'm going to run that. You notice here it presents, the data set is not big. It is about 74 observations. 12 variables. That is your columns. It even tells you the year where the data, like 1978 automobile, data, 13 April 2022, that's when it was updated last. And the list of variables that are in the data, you have price, you have make of the auto, you have price, miles per gallon, or mileage, then you have all these variables that are recorded. So this kind of gives me a structure. You can also see that there is, the data also tells you the measurement or the way the data in the variable is measured. Like when you come here, which says storage type. So when it says string, it means that the data is stored as a character. Int is short for an integer, which is a real number. Then float is a decimal point, numbers that have a comma. For example, 1.0, 20 point something and so forth. And byte is it can be your categorical data, it can be your binary data, right? So if you want to have a more sort of detailed, we want to have a more detailed sort of information regarding each data, we can just say, can you show us the codebook here? Then what the codebook does is it opens each and every variable, telling you it tells you both the variable name and then the label. So make means the make and model of the car, the way it's stored, whether there are any missing values in that data here, and the examples of the sort of values you're going to find in the data. So the different types of cars as well as the unique values. Then you go to the next one, it tells you its price. It even gives you a range for numeric variables. So the lowest value there for price is 32.91. The sort of the range of, and the highest is 15.906. It also calculates some other little bit of statistics like your average value, then the standard deviation, and then the percentiles. So you know from descriptive statistics the meaning of they call it your measures of central tendency. Like as we were discussing in the morning, that there are 3 types of descriptive statistics that we look at whenever we are doing descriptive analytics. We look at measures of central tendency. We look at such as your mean, median, and mode. Then we also look at measures of dispersion. The most common measure of dispersion we use is the standard deviation, right? Although sometimes we discuss the variance, but we want to use the standard deviation to understand how much is our data spread out from the average value. But in most cases, if your data is not normally distributed, meaning that the spread of the data may not be as informative because the data is not sort of homogeneously distributed. The assumption is a normal distribution. Then you have your median, which is the middle value, right? When you arrange the data in ascending order, the middle value is your median. Then the mode is the most common value, particularly, let's say we're collecting data on various categories, and then we graph the data. We're looking at the data with the largest chart or the largest bar, the highest frequency, that will be the mode, and so on. So when you're looking at percentiles, for example, like here you look at, you're given about percentiles from 10%, 25%, 50%, 75, 90%. So at each percentile is telling you exactly that at the value that is given, where that percentile is, in this case is 38.95. It's telling you that 10% of data values of values associated with this particular variable, they fall within the 10% of the data, like they're below this particular value. 10% of the data is below this particular value. 20% of the data is below 41.95 and so forth. Why is this sort of important? I want to interpret or be able to understand the descriptive structure of the data and to try to think about it in relation to what I want to do or the objectives I have in my study. If I know that maybe 25% of people in the data sort of fall below a particular value, how useful is that to my sort of analysis? Other important measures of position as well that you are familiar with are the quartiles, which sort of breaks down the data into 4 equal sections of about 25% each. So it tells you that when you look at the quartiles, similarly to your percentiles, but the information is quite different. To say, when you're looking at the value on which the 25th or the 50th percentile, the 25th quartile falls, or the first quartile falls, is saying to you that about 25% of the data points are below this point. Or it tells you that 50% of the data points, when you're looking at the obviously the second quartile, the same when you're on the third quartile. So these are what we call the main sort of statistics you look at when you are examining your data using descriptive statistics. So Stata does that for you simply with the codebook function. You are able to actually have a sort of to look into the data, what the data sort of structure looks like. So for your quantitative or your continuous data points, you can also perform, like if you want to understand some of the statistics, by just saying to Stata summarize. If I want to just run a summary to calculate the mean and these other maybe for all the continuous variables in the data, I can simply say summarize and run it, and then Stata also does. So you see all the continuous variables in the data, like your make, price, MPG, all these other continuous, as well as for your descriptive variables. You notice that the variable make was measured as a character or a string, and Stata cannot utilize variables that are strings or that are recorded as a character. You need to actually translate it, which we're talking about when we're referring to the issue of data restructuring or transforming your data. So Stata simply says 0, but when you go back to your code book here, you notice that make does not have any missing value. It has 74 observations with none missing, but it's coded as a string. So because Stata cannot use data in that structure, it simply says to use 0, right? Then for the data that is in numeric form, it's calculated the normal way. You're told the number of observations, the average value, the standard deviation, and you're also told the minimum and maximum values from which you can calculate sort of the range, which kind of gives you the sort of a feel to the description of the data. Look at that variable called foreign, for example, which was saved as a byte. You'll notice that the range, the minimum is 0 and the maximum is 1. Which tells that this variable is categorical and is binary coded. You remember the dummy variables, 0, 1, very useful in analysis, but obviously one reason why I also calculated all the summaries for all the variables in the data. You notice that yes, Stata is calculating the mean for every variable, even if it does not make sense. Like the mean for a binary variable here doesn't make sense because it's a variable that is coded what? 0, 1. But Stata tells you that is 0.297, right? So if you are not taking into consideration the structure of data and the methods, you are likely going to report that mean. And then someone looks at it and say, what are you trying to communicate? You do see this in research. I've had the privilege, sometimes, some statistician does some analysis, and then later on someone says, my analysis was rejected. Can you please guide me? And you are going through the analysis with the student, and you actually notice that, but this doesn't make sense. Like someone once wrote about 20 pages where they were calculating means for all the Likert scale data. And they even calculated p-values. That was very shocking. And then, like, as long as there are p-values, it doesn't mean that. When we need to have a sense of the philosophy behind the sort of metrics we are using when we are running the analysis. So every time you run something, the software is always going to produce something. It's always going to produce statistics. And if you are not really thinking about what you are doing, you are definitely going to be interpreting everything and then just trying to communicate those particular results. So I think when we use softwares or platforms for data analytics, and we also are thinking about the principles behind data analytics, and we integrate those principles in our sort of processes, our techniques, and our work, we're actually going to make sure that we are not just putting in garbage, but we're actually using the various tools that we have from those softwares for what they actually intended. I don't know if that makes a little bit of sense. Right. So these are some of the things that we can do in Stata, without having to go into a little bit of detail. I think I would want you guys to read that book, some of you, that I'm going to send. So that when we meet tomorrow, because I don't know whether you're silent and like, what is happening here? Or we're moving together. No. I don't sell stuff that I buy, at lower prices. Okay, so yeah, so tomorrow, I think, as professors have suggested, I think what we'll also do is to actually also communicate together with the do file. Yeah, so that when we are running the analysis tomorrow, everybody is also sort of following. Yeah, so what I wanted us to do today is to get a feel of what Stata kind of does and its capabilities. So I think it provides a good platform for data management. Sometimes you receive data that is in, when we collect data, when we create variables, we normally don't create our variables as, like, for example, in an Excel file. Like these days, we normally send out like your Google Forms, is it? Maybe I want to do an online survey. Your data, the variable names are not shortened, but they are like questions. And when the data comes, it's actually recorded as what? As questions. And you want to reduce the size of those variable names and also capture the coding. Sometimes what people normally do is they download into Excel file, make some changes in Excel, and then load it again into Stata. The challenge with Excel is you cannot put labels on the data in Excel. I don't know, maybe some people are able to do it, but when you are changing the variable names, sometimes shortening them, you might end up sometimes forgetting exactly what was the original. Then you have to go back to the original data. Stata offers functionality where you can do this together. So you see here is what we call the variable manager. So I always import my raw Excel files straight into Stata, open my variable manager, and then I'll be clicking on each and every data point, rename it as I choose, and then applying the changes. And whenever I want to put them in my do file, like for example, if I want to change this variable called Mac, and then I say apply, you will notice here that Stata actually said rename Mac with a capital. And I can take this piece of information, this code, copy it, and I can paste it in my do file. So the next time, if I want to, and also I can always put notes in my do file. So here I can say renaming variables. So the next time I want to rename variables, I don't have to go back to that. I can just make sure that I have the history of how I renamed the variable is stored in my code book, and I can always run it. Here is an example of a more maybe comprehensive do file. This is a study we did recently on the mentees data. So this is the data that was collected on students' responses to mentees, to their mentors, how they felt, their perspective on their mentors, and also their academic performance. So we decided to use that data to write a paper that was presented at the recent, conference on teaching and learning. So you can see what I'm talking about when you look at these, right? When you look at these variables, do you see the sort of names, how long they are? Like please enter the title of your, and then I rename it to degree title, right? But sometimes I can actually forget if I were doing this, maybe making the changes directly in the Excel file. So I simply imported the data into R, and then I codified all the changes I was making, saved it in a do file, and then when I close data, I say don't save anything on it. So the data set remains raw, but every time I want to rerun the analysis, I open my data set, rerun the analysis, have my results, and still also just save my do file and not make any changes to the raw data file, right? So you notice that it's a lot of work if I was doing it in a like I'm doing it in my Excel file, but because I'm doing it within Stata, I'm codifying each and every step I am taking, and I'm also keeping a record of each and every step I am taking. So yeah, probably by the end of this workshop, you'll definitely be understanding some of these codes that are there and stuff. So this is a typical do file I was running, testing, running all the manner from data transformation to running all the particular sort of analysis procedures we ran, from tabulations, graphing, to things like factor analysis, as well as even running t-tests and analysis of variance to check whether the scores we're observing of some particular measures, how were they sort of distributed among when compared over demographic characteristics of the students. So Stata enables us to actually do all these things, codify our research, and being able to store what we are doing, maybe seek advice whenever we are struggling or trying to find better ways or more informative ways of doing something, and still coming back to make changes to the data without actually having to lose everything that you're doing and then coming back to it. I think SPSS does a similar thing, but you have to save the output window all the time, but doesn't produce actually the code. So whatever was on the output window, it kind of just continues exactly the same, and which becomes a challenge sometimes if the output window has become too big and you have to having to scroll to look for the particular information that you want. But with Stata, you can go back to your do file, run it again line by line until you come to the information that you actually like. Yeah. So this is just a feel of what Stata is all about. I hope if this workshop doesn't do it, I am sure in subsequent workshops, and probably we might even create a forum where we can also begin to engage and exchange our ideas as we are working with Stata. So I'm sure also the subsequent sort of workshops are going to really cement your understanding of Stata. Yeah, I don't know if there are any sort of questions or aspects we should get back to. I'm not intending to cover the whole ground. Yes? Yes. When you yes when you yeah, Stata has macros, but I'm also sure if they mean the same thing. Yeah. Yes, you can do that. Yes, you can do that in Stata. Like if you just open a do file and not select anything and you just run do execute, it will just run the entire do file. Yeah, it will just run the entire do file. But we really encourage you to begin to learn to use a do file. It might seem a little bit harder as you begin, but it helps you to document your research, and it also helps you to communicate your research better. Sometimes when you submit to your work to other reviewers who are more, in very credible journals, or maybe in people who are really serious with their work, they are likely going to ask you exactly how did you do your analysis. So it helps you to really communicate, okay, these are the steps that I did take, and someone is going to evaluate your work based on what you were demonstrating, not based on what they are likely going to be thinking about your analysis. So we really encourage people to begin to try to make use of, these tools, these softwares that actually make research and the research process a little bit more easier. Yeah. Yeah.
Tomorrow, tomorrow most of data, and hopefully, Kawonga would have sent you.
Did everybody sort of write their email down? Then I know that I can just take the register. Or maybe you want to send me, or should I give you my email? Then you send me a blank email. Kumla has. Okay, fine. Okay.
Thank colleagues for coming. We hope to see you tomorrow.
Yes, definitely. Yes. But because I will have to work on it, I'm gonna send the book early so that people have access to the book while I then make whatever changes I need to make later. Yeah. Yeah, let me just talk to people online. I don't know if I can send a message so that if they need the book, I can just where can I chat? Chat. Hi everyone. Okay. No, I'm just communicating to people online.
We've been recording it.
I think that I won't be available tomorrow, so I don't know if I'll be accessing it.
There's a link, we'll try to send the link again to everyone.
You have all your registers.
I'm connecting. About 3, 4. Did you RSVP?